everyone. My name is Charlene Jin, and I'd like to welcome you to Kneron's virtual launch event for our next generation AI chip, the KL720. We're excited to share with you how this on-device edge AI chip will accelerate practical and secure applications for local AI in devices right now. But we're even more excited to share with you our panel discussions where leaders shaping the future of AI joined us to talk about what they see, from education to investment, from device makers to solution providers. Let's hear from the thoughts on how edge AI is making a difference in driving the growth of AI. But first, I'd like to introduce Albert Liu, Kneron's co-founder and CEO, who will introduce a bit about Kneron, our vision, and of course, tell you about the KL720. See you in a bit.
Hi everyone, I'm Albert Liu, founder and CEO of Kneron. I would like to welcome you to our online event today as we unveil our most powerful AI SoC today, the KL720. First, let me tell you a bit about Kneron. We are a global edge AI company founded in 2015. We have 6 global offices with our headquarters in San Diego, California. We have been early to market, commercializing products for smart city, smart vehicle, point of sales payment system, and security system. Our products including hardware and software solutions that enable edge AI processing and inferencing. We provide complete turnkey solutions for device manufacturers and solution provider to enable edge AI onto their product or their customer's product. We are a group of experienced scientists and engineers who are ultra focused about enabling AI for anyone and any device while maintaining users' privacy and data security. That's what we set out to do with our first SoC, the KL520. And it has been our singular goal all the way through the development of our new SoC. Kneron's SoC can bring on-device edge AI to anything with a sensor and enable edge AI with solutions that balance performance and power efficiency. The efficient performance that our chip brings opens up edge AI onto device and use case that our competitors don't and cannot serve. This can be seen in a number of the design win and many partners products already going to the market with our AI SoCs. After the success of KL520, we decided to support a new class of device which requires more power but still keeps the same class leading performance efficiency. So today, I'm excited to announce the launch of Kneron's new KL720 SoC, which is available now for public sampling. We have increased our performance to 1.5 TOPS while being more power efficient at 0.9 TOPS per watt. This is 2 times or even 4 times more efficient than competitors and around half their price. With this ultra power, KL720 can process 4K image and 4 HD videos to support flagship device with high-end cameras. It also supports natural language processing for AI assistant and smart translator, allowing them to understand full sentence commands and translate speech, rather than just simple wake-up words. Equipped with 3D engines that support step decoding, KL720 will accelerate the future of 3D AI and leave the 2D era in the past to much more accurate and secure facial, people, and object recognition. KL720 maintains our reconfigurable AI engine found in Kneron SoCs while significantly increasing the performance and power efficiency to service a different section of on-device edge AI market. To show this powerful combination, a single KL720 chip can enable both 3D AI sensing and full natural language processing. At the same time, in real time, through Kneron's reconfigurable AI engine and KL720's increased processing power. KL720 sits alongside KL520, enabling a new class of device thanks to its 5 times power increase and 2 times efficiency boost. To give you an example, while KL520 is an ideal chip to power AI inside a car where it can be focused on driver safety application, KL720 is perfect as an external car camera able to deliver automatic intelligent parking, traffic monitoring, and fleet management. KL720 is also ideal for Ultra HD security camera, drone, smart TVs, AR/VR device, cars, security systems, wearables, and many more applications. Imagine a smart TV with KL720 embedded. Not only could it open up gesture control, but with skeleton detection and natural language processing, it can now allow gaming to reach another level. Its support for increased resolution and enhanced processing power means it can process AI model to manage a group of people while processing multiple data points. And to re-emphasize, because KL720 is an Edge AI SoC, it can do all this without sending data to the cloud. This better protects users' privacy and ensures greater data security. With Kneron SoC like the KL720, it won't just be flagship device from big tech company that can bring the value of AI to consumers. SMEs that normally cannot afford to consider using AI now can create product and marketing value for their product line as well. Finally, KL720 plays a key role in powering NEO, Kneron's Edge AI ecosystem that democratizes AI for individuals and organizations. They can now define their own personal AI and create their own private network through Kneron-powered device. NEO creates a platform for developer educations, students, consumers, and SMEs to take advantage of the power of AI. Any device that using KL720 can connect to other Kneron-powered device over a private network, ensures total privacy and security, while also allowing those devices to work together in a sensor fusion to enhance their AI processing accuracy and power. NEO empower personal mobile AI and network for everyone, just as mobile phone and apps enable personal mobile computing for everyone. That's why a big part of NEO ecosystem are our effort in supporting educators with the right tool to teach AI to our future generations. Starting with UCLA, Notre Dame, and University of Virginia, we have begun to empower and support the next generation of AI developers and AI applications, especially in the classroom. We have already started working with alpha partners for the KL720 like Avisonic and ADMax on applying it in real-world solutions. With the Acer Link, we are building Edge AI box that allow group of older security camera to feed their video data into the box for local AI processing. And with Avisonic, the solution we are building will be used as car external camera for applications like automatic parking and people and object detection for traffic safety and insurance purpose. Any interesting solution providers and hardware makers can contact us through our webpage, www.kneron.com. Data sheets are available for Kneron's developers website for download. Thank you for joining us today to learn more about our vision for the future of AI. We have a number of panels featuring for our partners, industry experts, investors, and distinguished media that we hope you enjoy. I'll be back at the end of today's events for a Q&A session. Thank you.
All right, thank you, Albert. Looking forward to the Q&A later. Next, we have an interesting collection of leaders in AI, including device maker DJI's Romeo Dersher, solutions provider AAEON's David Hung, and our very own David Chen, Kneron's VP of Engineering. The panel will be moderated by Stephen Ellis, who covers technology for Reuters. So let's learn about what they have to say about embedding AI on devices.
Hi, I'm Stephen Ellis, a reporter with Reuters, the news organization, where I cover the semiconductor space. And I'm here with a great panel of guests today to talk about artificial intelligence done on the device. And so if we could, I'd like to have our panelists, David, Romeo, and Davis, all kind of do a quick introduction of themselves, just so everybody knows where everybody's coming from and who everybody's with. So maybe Davis, it'd be good to start with you.
Oh, sure. Good morning, everybody. I'm Davis Chen. I'm the VP of Engineering from Kneron, and I also look after the product management group.
Great. And then Romeo?
All right. Thank you very much. This is very exciting. My name is Romeo Dersher. I'm the Senior Director of Public Safety Integration at DJI, and we manufacture consumer as well as commercial drones. Drones have made a big impact, especially in public safety. Now with the wildfires here in California, once again, drones are coming in as a tool and a force multiplier. 3 years ago, we deployed to our first wildfire event in Redding, California, the car fire, and there we integrated AI module to help us in our work.
And David.
Hi, this is David Hong. I'm from AAEON Technology in Taipei. And the AAEON is the leading industrial computer manufacturer. And in the last few years, we are focusing to developing AI to our computers and our applications in the AI age and AI IoT related field.
Excellent. And so before I kick it off with questions, I just want to say thank you to all of our panelists from joining from a variety of time zones here. I know it's different times all over the world, so we really appreciate everybody being able to get here. I guess the first question that would be best, and maybe this would be good to start off with for Davis, is let's try to locate what we mean when we say AI on device. So if we kind of make a grid with 4 different quadrants on it and think about, inference and training, and then think about sort of a spectrum from big powerful chips that consume and the many watts of power in the data center, all the way down to devices that have very, very strict battery requirements because they've got to compete with a lot of other things in the system. What do we mean when we talk about AI on the device, and what's Kneron kind of tried to solve as an issue there?
Sure. Yeah, that's a very good question. So AI. So what we're trying to focus on is AI model that has been trained on the cloud, but the already trained model running on the edge instead of the cloud to give users a little bit more the security, as well as an AI device that are running mostly on battery or purely on battery. So we're focusing on the very ultra low power aspect, or the usage case of deploying AIs. So that imagine a device on the edge that are not connected to the power outlet, but on the battery. It could be on the DJI drone. It could be on an AAEON device. That are way out in the field in the remote areas. Basically leveraging the AI model to solve certain problems, living off of a battery, that will last 3 to 6 months, or in some cases up to 12 months. So the key is how do we take a already trained model from the cloud and deploy on the edge, converting from floating point to integers and be able to run on a very power efficient, ultra low power. So what we're trying to hit is this tops per watt. And that's where Kneron is focusing on, and that's where I think the usage model and the application gets very interesting. That will open up a lot of possibilities where computing or AI cannot go today. I think in the future with Kneron's chip, we can actually open up that possibility and enable those products and applications.
So that's a really good recap. David or Romeo, what are some, that's a very good general explanation, but I'm wondering if either of you could tell us about, some actual applications that you're looking at, thinking about, some real specific use cases that you're looking at or thinking about with regard to doing AI on device at the edge.
David, do you want to go first?
Well, you are from the DJI, and actually my example here is about the drone. Well, if you want me to take it, okay. And I think I would like to list a few points about the AI, what we need in the industrial AI. I think the first thing has adequate AI power, because in my industry, sometimes we only using AI for a single task, like a visual to recognize some certain objects. And the second thing is the size has to be small, because sometimes my computer board is only the size of a palm or even the size of a credit card. And the last two things is the low power and flexible. So using Kneron's solution, it is only 0.5 watts, just like what David said. And another benefit of low power is we don't need any cooler. We don't need any heatsink on top of it. So we can make a whole application fit into a small enclosure, such as using on the drones or in a mobile robotic in the field. I think that's what our application is. Yep.
Yes, thank you, David. You know, the drone is a data collection device. It's a camera that can operate in 3D space. And what we're looking for are data points. And oftentimes, as a drone operator or a visual observer or somebody who looks at the footage in real time, a lot of information are coming at them. So using a proper AI model, we can really help an operation. And I'll give you a couple of good examples. As I mentioned earlier, when we deployed to Reading to the car fire in 2018, we had developed an AI model that helps us locate burnt or damaged buildings, burnt or damaged vehicles, so that when we fly over a community, we immediately get actionable data. We get a count of how many homes have damaged or destroyed, how many vehicles are destroyed, so we can time. Another one that is of very big interest, again, in public safety is, for example, search and rescue. With the help of an AI model, we can easier detect signs of a human being. Maybe there was an accident and a person lies under a tree and only the feet stick out. And so it's easy, for an operator to miss that, but the AI model can then help with the detection of those feet or a piece of clothing or whatever the case may be. And then in inspection, especially like power line inspection, where we're looking for corrosion and items that are broken. And so training that model to look for those items and highlighting them really brings a huge ROI to the operation, because we're saving time and we're mitigating the risk through AI models.
And so one of the things that David brought up was having sufficient sort of AI power. And one thing I'm wondering if either David or Romeo could talk about would be what do we mean by that? And how much training has to go in on the front end in order to get those really good results at the edge? And how much does the performance of the chip at the edge play into that?
This is a very interesting topic, and my focus mainly is on the public safety side and our technology. When I first learned about what it takes to build an AI model, I was amazed at how labor intensive it can be. However, over the last couple of years, those algorithms have become so much more powerful that it doesn't take as long to create that initial model, and then it continues to learn thanks to the capabilities that we now have in the technology sector. And so it becomes much more interesting. Before, when you had to use 10,000 images and categorize each image, that was so labor intensive. And some of the smaller models that we've helped create, they've used 50 images and maybe 2 minutes of video to already bring strong results. And I think that's really what makes this so much more applicable and interesting.
Speak of the AI's model and the size, I think for my portion that we are focusing on the light AI models, which like a YOLO type and recognize 100 pieces of object at a time. And that is enough for our customers to using it in the field applications, such as drones or the bending machines, to make sure each items are in the right angles.
Yeah. Another thing that came up was flexibility of these chips. And I wanted to go back to Davis and ask a little bit about software. So one thing that's always important when you're designing silicon, right, is the stack and what's gonna run on top of it. There's been a lot of change and evolution in the software space. And so, Davis, I'm wondering if you could talk a little bit about, you're designing a chip. It takes a certain amount of time to get to tape out on a chip, but that amount of time is not necessarily sort of the same kind of time frame or time scale as software can change in this space. So I'm wondering if you could talk about what kinds of software and frameworks and things are you trying to aim for compatibility for, and how do you balance that when you're trying to create silicon where that process can sometimes be on a much longer timescale than the evolution of software and in a space like artificial intelligence. So what kind of software are you trying to work with, and how have you tried to keep that current with what's going on in the field?
Sure. So yeah, as always in the technology sector, the key is to be able to adapt, right, and also be able to adapt very quickly. And that was a very good question. That as we develop a silicon, how do we make the best use out of the silicon in terms of what are the AI models, AI framework that we can support. And we have made a lot of advances in providing many converters. So we'll be converting from all the AI models that are out there, sometimes utilizing the open source software, sometimes utilizing our own proprietary software to convert all the models into Onyx, the open neural network exchange framework. And once it is converted to Onyx, then we go through prunings and compilings and all the compressions to kind of get the models down to the size of at least 50 megabyte or less. And that's where I think it runs best, on our chips. And like the question states, we have to adapt, and we don't get to roll out a silicon, every day. So another thing that we do is in the pre and post processings, where we enable, for example, running a CV algorithm, as a filter, as like a first stage and second stage, so that if the CV algorithm, as a first stage, see something that are of interest and filter out, things that are of, not as important, and that's where we can optimize. And basically, you don't really need to wake up the MPUs to do the work if the CV already see that, or this is unrelated image, or this is an object not of an interest. So that's how we kind of combat and adapt to change. And in the pre and post processing, there's a lot of things, a lot of creative ideas. Some of them are to save power. Some of them are to utilize the algorithm better. Some of them, as I mentioned, is just to basically decide when to kick off the MPU or not. In terms of having two layers, and that give you a little bit more granularities in terms of software designs.
Great. And I'm wondering, David or Romeo, if you guys could talk to that issue too. I mean, you guys are in an interesting position where on the one hand, you've got system decisions to make, but on the other hand, you've got customers who you're either going to work with them to design software, or they're going to bring software. So how are you thinking about these issues in terms of, trying to sort of, hardware designs are similar in as much as they take a while to bake, and then they tend to stay baked for a while, regardless of how fast the software moves. How are you guys thinking about this issue when you decide, your bill of materials and kind of what you want to put into systems? Are you looking for things that will give you that flexibility in case some hot new framework comes along, a year and a half from now? And maybe David, it'd be good to start with you, because I know for some of these industrial things, the amount of time they can be expected to be in the field can be pretty long compared to consumer, or even sort of even other enterprise devices.
For the software side, actually we are relying on Kneron's SDK, and actually our customers can leverage their SDK to make more of their models. Not just that, they also using the models in the open source, and then they modify the open source things into what they need. So I think this is one of the great technological software improvement, because people can using the open resources and then convert it into their applications to fit in what they need. So I think most of our customers actually using Kneron's tool chain to convert the tools into the Kneron's solution. Yeah.
And for us, we also have our own SDK for our drones, and a lot of solutions come through the SDK. Obviously, we have a little bit more flexibility as well in regards to how we want to apply an AI model. In the future, I think the AI will reside on the drone itself and potentially even have connectivity from the drone. But right now, we want to keep our drones as compact as possible. And so what we're seeing is that oftentimes the drone footage is being streamed potentially onto a server, and then at that location, you run the AI algorithm on top of the data stream that comes in. Obviously, there's a little bit of a delay, but that's okay, because it's not very significant, and you can always figure out, like if we're doing a search and rescue operation and the AI model picks something up, but it was not live on the drone, it was in the back end on the streamed footage, there may be a few seconds delay, but we know where that location was because of the telemetry information that's part of the data. So that delay doesn't really make a difference. I'm really looking forward to more of these applications being on top or inside that vehicle, and not having to rely potentially on a live stream, solution.
Yeah, I'm wondering if you could talk a little more about that, because as we're talking here, we're mostly talking about the world of a trained model that's been trained somewhere else, presumably in a data center, maybe on a workstation, depending on the scenario, and then essentially pushing that down, to the edge. But one of the most fascinating things about AI is its ability to self-improve based on the feedback that it receives at the inference stage. So what does the future look like there in terms of, starting to push back some of that data that you gather in inference, right? And to eventually refine the model? Because when AI goes from interesting to potentially really, really, really interesting is when you start to get that feedback loop of every bit of data that's coming in, especially with network devices. For example, is there a world where you might be looking at something from 2 or 3 different angles with 2 or 3 different drone devices, right? And then you can say, aha, we found a snag in the model where there was something we consistently weren't recognizing that we wanted to recognize. But now that we've seen it from 2 or 3 angles, we can push that back into the core model. So what's the future hold there? Where are we on that at this moment?
I think we're already seeing some of that happening, and it's extremely fascinating. I'll give you a good example. Let's say our drones, they have a GPS inside, and so they know where in 3D space they are. If you initiate a return to home, it knows where it took off, and it will autonomously fly back and land itself. Now, if we do an operation indoors where we have a no GPS environment, GPS denied environment, we can't utilize that feature. So drones have a variety of different sensors on them to kind of, scan their environment, and based on that, try to avoid obstacles. Now, if we're flying in an indoor operation, let's say it's a hazardous material one, it's a big warehouse, we don't want to send in individuals, we send in the drone first, and we fly this drone into the warehouse. And with all the sensors, it starts to already build kind of like a rudimentary model of the environment it is in, and through that then know how to fly back to not, bump into things or not find the exit out. And I think we're starting to see all of that now happening on the drone, and the drone learning its environment and then using that data to navigate itself back to where it came from.
That's interesting. Does it have any, can you eventually, so what do you do with that data once you've navigated back to where it came from? Like, at what point can it get pushed back up into a, or does it ever get pushed back into a model, or do you just kind of keep that in cache on the device as a localized, kind of indicator of a localized environment that you've mapped?
Both, actually. So you have the ability to live create that model at the operator stage, because that data is all being transmitted, and you can already create a rudimentary model. It keeps it also on the drone, so that if you have to go back in there, it already has that model that it created in its brain, in essence, to help navigate through. So the autonomous factor definitely will continue to be built and utilized more and more, especially in indoor environments. Right now, the regulatory environment for flying autonomous outdoors is a little bit different, as it still needs a pilot in control that can jump in and take over if need be. But again, I think with the AI component in the future, this will become more and more safe to do autonomously, because the drone in essence will recognize its environment, its potential threats that could be in the environment, like birds or crewed aircrafts. So very, very fascinating outlook into the future.
Yeah. And, David, I wanted to kick that over to you a little bit. One of the things that was mentioned was sort of a hazardous materials indoor situation. You can certainly see a lot of scenarios in the industrial world where it might be good to start sort of building a local model there. Is there anything that you guys are seeing on that front, or thinking about for the future, about like, hey, maybe these devices need to build and refine their models in the field?
Actually, in my field, I can see that people are using AI to handle some lousy jobs, such as using the human's eyes to do the inspection, or in one of our vehicle applications, that application or that solution using AI's camera to count how many children get on the school bus. And if there is anyone missing, it will help the driver to send a signal or send a call to the home or to the school to inform them, hey, I didn't have these kids on the bus at this moment. And by using the camera, it also monitor the driver's eyes to make sure the driver is in the good status to driving to bring them home or to bring them to the school. So I think AI will be our good assistant in the future, and it will supporting humans to do their job to make it more precisely and to make things more safely.
Interesting. So another thing I want to touch on is cost, because that determines a lot. One of the reasons we're even able to talk about all these interesting things we're doing with cameras is the humongous decline in digital camera sensors over the course of the past 20 years, where the quality and size you can get for a very small price is just incredible. I still kind of remember the days when there was still talk about digital versus film or video, etc. So those days are long gone, and that cost curve has come way down. Davis, where are we on the cost curve for, maybe the way to think about it is if we look at it at a given tera ops per watt, where are we on the cost curve right now, and where is that headed, and how is it going to stack up to things we're more used to talking about, like mobile CPU, right? Like, where are we now? Are we where mobile CPU was in terms of cost of processing unit in like the mid 2000s? And And then what's that curve going to look like is more and more companies get into this sort of vigorous competition for AI at the edge.
Oh, yeah, that's a very interesting question. So, the technology have advanced, tremendously. Today you're looking at a, ARM-based single board computer that are in the price range of say $30. That can rival your Windows PC. That were running for Windows just a few years back. In terms of AI application at the edge, we're looking at building a device also at the potentially $30 range as a whole device. And imagine that you're running this device 6 to 12 months. It's almost like a throwaway, right? People pay for video streaming services $10 per month, and if this is some device that are $30 $50 price range, where it operates in the field, like both gentlemen are saying, from DJI and AAEON, in a mission critical environment where safety of the operator is of a prime concern, or of a very tedious and lousy job. And imagine $30 or $50, you get yourself a device that can be throwaway, if it operates 6 to 12 months. And especially when it operates in an area that are that could be very tedious for humans to perform, or it could be very dangerous for humans to perform. It could be a very harsh environment. It could even be a dangerous condition where they are dangerous gas. And it's just tremendous capability where we are growing the outreach, right? One thing that we're growing the outreach was the battery power. As you can operate off of battery, you open up possibilities. The other thing was, streaming, where you are basically limited by the 4G or 5G network, where you're constantly streaming back the video image that are collected. Since we're doing the AI on the edge, we don't need to stream back all the images and the video, so that further open up the outreach of where you can deploy this device. Right? And where we expand this further, into these, dangerous areas, dangerous environment for human to operate, and maybe more into, AAEON's application is, you really get into this very, very niche or very remote area where, you put like 2 AA battery and it should operate for 6 to 12 months. And then in the end, maybe before it ultimately shuts down, it had gathered enough data, right? And these data are not in the image or video format, so it's much, much smaller in size, where you could finally, send back all the data through an NB-IoT. So yeah, so going back to address the question, the costs have really come way down to the point that it's almost like a disposable. It's like in the old days where you have very expensive cameras and then you have disposable camera, and now everybody is using a digital camera. That the fact of having a camera or bringing a camera is it's not in the mind, because you will always have your smartphone with you, and everybody has a camera. In fact, everybody has multiple camera, and it's always with you. So we sort of go from an expensive camera to a disposable camera to not even have to think about camera. Camera is by default almost like a basic human capability. And I think in terms of AI or having AI at the edge, or having multiple AI, helping you with, making your life more convenient, or making our world more safe, it will become so default that it will be everywhere. That's my opinion.
Yeah. Well, and one quick follow up on that, and then I want to be mindful of our time. We're getting close, and I do want to get a little bit more from DJI and AAEON, but. Quick follow-up on that, with the power you're at right now, and I think if I remember, it was half a watt. I might have said that wrong, but with the power you're at right now, what does the curve look like in terms of getting that down? And what's the timeline for getting to things like a coin cell battery, like we see some of these Bluetooth Low Energy devices using right now, and then way in the future, is there any possibility of using things like various wireless power transmission technologies to do this kind of stuff, where you could potentially power things over, maybe not a huge outdoor environment, but even an indoor environment that's fairly closed in without having to have any direct battery attached. So what's the power curve look like for getting to, coin cell battery and even crazy science fiction wireless power transmission to power this kind of stuff?
So question
that one would be for you,
okay,
Davis.
sure.
And then I want to ask DJI and AAEON what they would do with such crazy sci-fi stuff in the future. But what's it look like on the power curve?
Sure. So yeah, the power have come way down. And when we design the silicon, when we talk about the 1.5 tops, or when we talk about 0.5 tops, what's important to remember is also the tops per watt. And and we're hitting 0.5 tops per watt, or sometimes we're hitting 1.5 tops per watt. And these are the ceiling capabilities. And like we talked about it earlier with the software, having pre-post processing. The other interesting things with the software is that we get to regulate the clock. We get to regulate how fast the chip is running. So basically, essentially, we get to regulate how many tops the chip should be running at, and that then dictate on how many watts it will consume. So having a chip that will operate at the 1.5 tops per watt doesn't mean that you always have to run it that fast, or that at that power level. I could actually tune it way down, for a specific application running only 0.3 tops, and in that cases I'll be consuming very, very little wattage. And if coin cell is a requirement, and maybe that will be the way to go, and that basically can be dictated by the software. So I would imagine that when deploying these devices out in the field or on a drone, it could dynamically adjust. Right. In some cases, the CV algorithm can determine that, well, for this cases, I'm going to load this heavier model, and I probably need to run my NPU at the 70% capability, consuming 70% of the power. Or this is a scenario that I'm going to load this very tiny little model, and I'm going to run the CPU at 20% and consume only 20% of the powers. And so you can see that how much power or how much capability it can be dynamically arranged, and that will save a lot of powers.
Great. And then David and Romeo, just any last, use your imaginations. What kind of pie in the sky stuff would you be interested in doing if these things were of negligible cost and negligible power footprint?
I think from a drone perspective, I would say scale. For example, with the California wildfires, if we had thousands of these, medium-sized drones that had the capabilities to scoop up water and just, thanks to AI, fly information, keep like a constant supply that just goes from a lake to wherever the fire line is and just drops and goes back. Or swarm technology, swarming for search and rescue. Multiple drones that help cover certain areas where it may be too dangerous for boots on the ground to go to, like a cliff, but with 5, 10, 15 drones covering that area and all flying information, following the landscape. I think those are amazing applications that will not only save lives, but help our first responders to stay more safe.
And David?
At my side, most of my applications, they are using fixed power. So for the battery side, it's most for a backup purpose to make sure the whole unit can still running for like 2 or even 8 hours without any power attached. So that if it is using like a life-saving or some critical environment applications, it can still sustain for more hours. And as I mentioned before, in my field, we want the AI application to be as small as possible. So if we can using a very low power AI solution, that means at the same size of battery, I can make my application to live longer. So yeah, we need a low power AI solution for this.
Got it. Great. Well, I think we've about hit our half-hour mark here. So I just want to thank everybody again for taking the time to do this and talk about AI on the edge. Fantastic conversation here, and I hope we can all talk again soon.
Well, thank you, Stephen. It's been a pleasure.
Thank you.
Thank you, Romeo. Thank you, David.
Thank you, Davis and David.
Thank you, everyone.
That was certainly very informative, from how DJI drones can leverage Edge AI in search and rescue missions to how AAEON's Edge AI solutions enable their customers to find ways to work in tough environments. We see why Kneron is so focused on balancing low power and performance for Edge AI applications. So up next, let's hear what investors see from the point of view on investing in AI. Let's welcome Nancy Yang of CloudAlpha Capital, Sung Mao of Qualcomm Ventures, and Arjun Karpal of CNBC, and see where the conversation takes us.
So Nancy, I just want to kick off with you. You've invested in companies from chip companies through to autonomous car companies. What is your investment ideas, your investment thesis around artificial intelligence?
Sure. I'm dedicated in this area. I have been investing since 2012. For the private companies, I invested more than 10 companies, including Horizon Robotics. I'm the first investor of that company, and also autonomous driving company, Neuro.ai. And Kneron. And then, so my thinking for the long term is that, I really believe that in the future, if you're looking at the human history, and the more and more and technology development trends, there are two major trends that is facing to the mankind. First is one, more and more people will live in the virtual world, and secondly, human participation in the physical world will becoming less and less, and they are all happening now. So eventually, we will be having we will need the enabling from the machine, human, robotics. But for those personal intelligent robot, it's a great thing. But now it's too early stage. It really requires a lot of it's wonderful things, but it's it's a very, very long term. For now, we should invest in each parts of it who can enable those things happen. For example, for human, for future human home robotics, the most important thing is the sensing. So I invested in the robotics autonomous driving company who are specialized in the sensing, which is a most important part for the future home robotics, and also chips, and then each part of it will lead towards my future dream of that. Yes.
And Song, for you, one area you've been focusing on is Edge AI. Can you just lay out for us what that really means and essentially how that feeds into your investment thesis?
So actually, Qualcomm China was started to invest in AI part since 2014, 15, that age. And our idea about AI is at that time we started thinking about, okay, AI will be a very big thing. The big thing means that this technology will be impact on almost every perspective of our lives. So for the first stage, about 2-3 years, we started investing in the very key and core technologies in the AI sector. So we invest in the SenseTime and Kneron for the computer vision part, and also for the Unison and also the AIoT from the voice part. And after that, we noticed that there are very massive kind of business model can come out in China market. So we started investing in two directions. Number one is we invest in the AI applications, the use cases in the verticals. So like autonomous driving, ADAS, or within all the detection part. So that is AI to replace the human labors. And another direction is that we start to invest in the long tail kind of AI platforms. In that case, is that that use case is not very accuracy oriented, but it's long tail and cost sensitive kind of way. So we invest in kind of a company called Extreme Vision. the funny part is we noticed that for the age part, the age AI is becoming a very clear trend. And the point I want to make is that if we're looking at the age AI, or we look at the whole thing is called age computing, you can see that from a lot of third-party research. It says that by year 2025, that's 75% of the data is actually be processed by the decentralized the processors, and we have over 30 billion kind of a device connected. But if you're looking at the driver behind, is that we have several trends here. Number one is the demand for latencies. So we have a lot of use case there. We require a low latencies, such as like autonomous driving, right? You can never imagine if we have to send the data from the terminal to the cloud process and goes back to that cannot work, right? And number two is we call it the demand for the cost, which means that for the especially for the AI part, right? Because comparing with traditional sensors, the AI sensors such as camera or voice, microphone, they will generate a lot more data than the traditional sensors. So it's really not cost effective to transmit all the data back to the cloud. And the third thing is about privacies and also the securities. So which means the AI, funny part is AI is the way to help the machine to understand the human world. So if we use the cameras or the microphones, the message or the information we collect is very, very private. So all the things add up together is the key drivers to we have to know that the age AI is coming, and we have to accept that.
Well, that's a great way to lay out the scene for us, guys. So I want to talk a little bit about what's happening right now, because, of course, we've got the ongoing coronavirus pandemic. And, a lot of the conversation from technology companies has been around the fact that, oh, look, this has really accelerated some trends, either whether that be e-commerce, the increasing digitization of various industries, working from home, etc. I mean, we're doing this over a Zoom call right now rather than in person. So when you look at what's happened as a result of the coronavirus, how has that changed or your investment thesis? How has that sort of changed the trends you're looking at all, or has it in any way? Nancy, let me start with you.
If we think about this, for those factors which can be causing the structural changes to the sectors, we're starting to looking at from the application side. We observed that application side on the consumer side, there's the obvious trend, the increased adoption for the work from home, and you might see paradigm shift on the applications on e-commerce, food delivery, and entertainment, and education, etc. It has changed a lot. And then on the enterprise side, for those when it requires no touch in order of working use case, so it will largely speed up the AI enabled medical in different value chain, including diagnosis and also in a pre-diagnosis, and also an AI have more collaboration with auto. You might see a lot of food delivery using the autonomous cars instead of the food delivery person, and also delivering the goods to the areas, hospital, etc. Those cars, and also you see speed it up for the AI collaborate with retail, or there's where there no one serve you, but you can still buying stuff, and especially the AI plus the manufacturing during the coronavirus period. There's not much factory still working except Tesla China factory, because it's fully automated. So this really will speed up the adoption for automation for those manufacturing companies, and then because you have those drivers from the application side, on the C side, on the consumer side, for the household, they might need to have the demand to buy more iPad, more screens. You're gonna have the demand for replacing a new iPhone, etc., to have a better work from home experience, and for your kids to educate online. So devices have a very strong demand, and then that will drive the cloud development. The cloud companies are adding capex on the servers. It's driving more data. It requires more storage, more computing. So it will definitely speeding up the computing chips and storage, right? So then it will go to infrastructure. So have a big impact to the infrastructure, data, cloud infrastructure, cloud. So we see that trend is national, globally, and also together with those, especially I want to mention China. China played a very important role for this global, coronavirus thing. Yeah, China contributed a lot. So together with that, we see more and more is acceleration for China's own replacement cycle for those semi and hardware company. It's together with the China-US tension. So all those factors adding together, there are a lot of structure fundamental changes to our technology sectors. It's definitely a very positive thing. Yeah.
And Song, from your perspective, where are you seeing any kind of changes happening right now as a result of the pandemic?
Yeah, I actually agree with you. I mean, the coronavirus things actually is, I'm sorry to say this, but it's a very positive kind of signals for the AI development. So what we've seen is, before this coronavirus, I have kind of, when I look at the companies who doing this AI labor replacement, there is always kind of pushback from the company side or the factory side, because to replace labor is a really hard thing to do, which means they have to change their assembly line. They have to fire or lay off their workers. They have to change the whole layout of their factories to deploy the new machines, right? But after coronavirus, their demand for labor replacement by machine is more urgent and solid. So because what happened in China is, for the labor intensive kind of work, it is not very easy and healthy to lay a lot of people working together, because it's kind of dangerous. And even more is that during coronavirus, during the Spring Festival, when the workers going back home, it is really hard to get them back, because sometimes the city just blocked down, right? So, and which means the labor kind of became unstable for the factory side. So right now what I'm seeing is that, from 2B side, is that almost every factory is seeking out a way to find robotics, find AI solutions, machines to replace the humans. So what happened in the testing world, which means a lot of testing workers be replaced by the AI things, and also call centers. You can see that the call centers, a lot of people, right? So they utilize the AI things to replace the human beings as ours. Yeah, that's what happening.
So let me just follow up with that as well, because you're obviously very positive on the momentum that's happening right now in artificial intelligence and development of that. But where do you see some of the big challenges coming along the road? Is it coming from regulation? Is it coming from, what we're seeing globally around this tech decoupling happening between the US and China? Where for you, Song, are the challenges right now?
Well, the challenges here, from really pure business perspective, the number one challenge is about the cost. So every factory will have this kind of thinking about, okay, if I want to replace human beings by machines, so how we change the cost structures, right? So like for the laborers, human beings, you pay them monthly, but for the machines, you pay them upfront. So what is the payback time? And here's the thing I mentioned about AI, why it's very important. Think about this way, just give you one example. We have invested in company who doing the bearing and the loader kind of testing things, right? So in the assembly lines, every 1 second, there will be 3 loaders or bearings coming out. And previously, they just utilized the humans, kind of testing workers to do that. However, if you replace with the machines, for each one loader, you will have 10 cameras behind to looking at it. Each camera will just picture it like 30 frames per second, and each frame will have 2 million kind of pixel resolutions. So if you utilize the AI kind of GPU servers to process all this data, that is almost impossible. And not to mention to send it back to the cloud side, right? So you have to do the local things, and you have to do better kind of cost-effective ways to do that. That's why we call it Edge AI. It's very important. So what we do is we actually separate the computations to put part of it in the camera side, part of it in the edge side, and part of it in the cloud side. So that the company side, the faculty side can accept the cost-wise to replace the humans. I think that's number one challenge there.
And Nancy, for you, I mean, in your last answer there, you mentioned that the rising tensions between the U.S. and China. Do you see that as a issue or a risk for the development of AI technology? You know, a large part of what the argument around the conversation between the US and China is around data, and it's around where data is stored, where data is going, and AI, of course, is very heavily reliant on data. So how do you see the risk from the rising tensions between the two countries?
Let me start from, the development of AI has experienced, the hype stage triggered by, the AlphaGo defeat human in 2016. And then there's a disappointment caused by, the difficulty of actual landing the use cases in after that in 2018, and then emergence of ethical issues such as deepfake, those fake videos in 2019. But now I think overall, we're now entered a stage of the steady and a realistic stage that about to rise. And now under this China-U.S. tension, this background, I think that there's nothing can really stop in China from on the demand side. There's only some bottleneck on the about 28 nanometers, and for the really high advanced nodes. And then so I think there's for China, the organic driver for the developing technology AI is still, I think, nothing different from previously. It's really developing really fast, driven by strong demand side. But however, if we're looking at for the longer term, I think if we really need to develop the high end, I think that some issues need to be solved. The bottleneck things like EUV, etc. So I think there's still some uncertainties, but for now, I think there are some solutions around that. So for example, like High Silicon, they license their IP to those startup companies. So it might have some, so get around with those regulations. So I'm still very positive, bullish for the future for the AI development in China. Yes.
Song, I just want to ask you quickly about another, trend that's been happening in the world of technology, and that's really about regulation, increasing regulation, or at least increasing talk about regulation towards technology as a whole. Do you feel that will play or is a risk factor going forward? The European Union, for example, talking about regulating facial recognition. The US talk about regulating some of the big technology companies with AI as part of that. So is regulation a key risk on your horizon, Song?
Well, we definitely need to consider about regulations. Right? There's some factors there. We see a lot of the regulation kind of issues happen around the world. But you know what, you just say this way. So in general, the convenience and the security are a trade-off. It cannot just happen at once, right? So if we give the people more convenience, that means you sacrifice some of the securities there. So the regulation actually helps on this part. We can just find out the balance between these two. So we have the regulation there. Maybe we find a way to balance, to under this regulation, we still can do the facial recognition to give people this convenience, because convenience is kind of a demand. If you're looking at back about our history, all our new inventions is about this make people life better. So I'm positive about that, but definitely I will looking at the regulation kind of factors when I do the investment.
Cool. We've got so much more to talk about, but we're almost at the out of time. So I just want to finish off by asking you each a question. Forward looking, give us your best investment idea, your best investment trend. What is it? Nancy, I'll start with you.
I still from on the big platform company, we still believe in TSMC, and then companies like Nvidia, who have benefit from the longer term structure trends, and for early stage. Still looking for application driven for autonomous driving for those, because auto EV is developing really fast in China or globally, is across the chasm stage. So I think that although there's long cycle, but for a company like Kneron who target really earlier, companies that we really have high expectation for.
And Song?
Well, it's a very tough question. So, yeah. So what I'm thinking right now is that we actually at the time point from 4G to 5G, and based on our observations previously, we said for every change for 2G to 3G, 3G to 4G, to 5G, after the bandwidth goes up, the latency goes down, we can always see a very brand new kind of user behaviors coming out, and can just give birth to a really good unicorns. So what I'm looking at is after the 5G actually launched, I'm looking for some kind of new user behaviors use case within the 5G world, the real 5G use case, and something, make people more comfortable to use 5G, and something only 5G can provide. But behind that, that means for the infrastructure wise, for the device wise, for the module wise, there will be a chance to supporting that. That is what I'm thinking right now.
Fantastic. Nancy and Song, thank you so much for your insights. That was a great conversation. And for all of you guys watching out there, we really hope you enjoyed the chat just there. Thank you from all of us, and stay safe.
Cool.
Hearing different perspectives really help us consider the Edge AI story holistically. After hearing from the investment side, let's see what educators too are seeing from the academic point of view. As Albert mentioned earlier, Kneron is greatly invested in supplying educators with the right tools to make AI development accessible at all levels and classrooms around the world. We see it as an evergreen driver for the future of AI. So first, we'll listen to Professor Kylie of Princeton, Professor Tsing of UCLA, and Professor Kong Shen of the University of Virginia, who joined Max Molax from AI Business to discuss their thoughts on teaching AI development today.
Hello, and welcome to this panel on AI and education organized by Edge AI software and hardware vendor Kneron. My name is Max Molex. I'm the editor at AI Business, the publication entirely dedicated to artificial intelligence in business. I will be moderating this session and asking a few questions. And our panel members today include Professor Kylie from Princeton, Professor Kong Shen from University of Virginia, and Professor Tsing from UCLA. Thank you, gentlemen.
Thank you.
I'm a professor at Princeton University in computer science department. My research expertise are in the area of, in several areas, in computer architecture, in distributed parallel systems, and also in building knowledge base. For example, I and my former colleague co-led the development of ImageNet, which helped propel the deep learning to become a dominating approach in machine learning. And currently I'm teaching courses, graduate courses in systems of machine learning at Princeton.
All right. Thank you. And Professor Kong Shen?
Hi, yeah, this is Kong Shen. I'm on the faculty at the University of Virginia, and I'm with the Electrical and Computer Engineering Department. My research and my expertise are largely on wireless edge intelligence, edge AI, but with the application more on the wireless end. And more specifically, I'm working on problems such as how do we enable large-scale distributed machine learning over, for example, wireless networks, and how do machines collaborate with each other to perform learning for a central task, and how does wireless communication or wireless network affect the learning performance. And before coming to University of Virginia, I also had quite a few years of experience in industry, mostly in wireless communication companies such as Qualcomm. I got my PhD from UCLA quite a few years ago. Yeah, that's my background.
All right, thank you. And Professor Cao?
Hello, thank you. I'm a professor at Mechanical and Aerospace Engineering Department at UCLA. My background, my research areas is in control systems, robotics, and something called mechatronics, which means integrating mechanical, electrical, electronics, and software as a system. And that's sort of the area of my research, and it's also the classes I teach that involve from theory of controls to all the way to student design project that realize this type of systems. And so far, AI has only been considered and sort of been explored in my research projects like surgical robots research and unmanned aerial vehicles. We haven't really adopted AI in our education, like courses, in required courses. Yes.
Okay, thank you. Yes, it's an interesting time to be in AI, absolutely. An interesting time to be sort of on the education side. What do you think about the supply of skills at the moment? So many organizations sort of like have highlighted that the demand for, you know, like specific workers with specific skills useful for AI, data scientists, data engineers, you know, like people who can design silicon, it seems to be increasing while the supply of the skills is not, you know, like if anything, universities sort of like are in a bit of a crisis right now because of the pandemic. So how do you think we solve this problem? Because there's clearly an interest among businesses, there's appetite to invest in AI-led projects. How do you think we're going to get enough people to build all the cool stuff that we want to build? And I guess we'll start with Professor Kylie for this one.
As you said, I think there's a very strong demand in the industry and in the society in general for machine learning or AI. I think that the education systems, my personal feeling, the education system is still experimenting how to teach courses. Typically, if you look at the history, when the new technology emerged, and educational system obviously have professors doing research in the front end, and you know, together with that new direction. But to educate a large number of students, to equip them with the knowledge to respond to the demand, I think that's require several iterations. You know, the iteration of developing a better textbook, involving a good set of projects and a good set of lab equipment. I think that requires some iteration. We're still, my view is we're still in the first iteration. So we're still learning about what's the best way to teach students. And most of the universities have close interaction with the companies. So we do get feedback from them, especially when the students going through the interview process. Also, we have shared collaborations. We have collaborations with various industry partners, and they will tell us what type of students they expect to have and what type of students they're interested in recruiting in the future. So we're constantly adjusting how we teach students right now.
Mm-hmm. Okay.
One example is that, for example, in computer architecture, I think more than 10 years ago, John Hennessy and Dave Patterson developed a very good textbook. And after that, I think a lot of universities or many departments adopt the same textbook and have a similar teaching style. But before that, I think there are many different textbooks, different universities teach differently. I think so that I feel like that particular round of iteration was towards the end of the iterative development of teaching computer architecture, for example. But early on, there are many different ways of doing things. We are at the early stage of doing, figuring out how to teach AI and machine learning at this point.
Okay, thank you. Professor Kong Chen, what do you think? Like, is it interesting to be like in a place where there's very little existing methodology? Where you have to invent methods to teach your students?
Yeah, I think actually I totally agree with what Professor Lee just mentioned. I think we are at the very early phase of figuring out how to systematically and effectively teach AI and machine learning and data science in general to students. And this is mainly because this is obviously a field that is, developing really, really fast. It's not close to being mature yet, So I think just like every other field, the research always comes first. That pushes the boundary of the field. And then the education kind of slowly catches up after that. And also, generally, it takes time, I think, for educators, because many of the educators, like myself, actually are also researchers. So we kind of have to put both hats on. And the research hat is obviously very different from, teaching, because you are thinking about new things. You're thinking about how to push the boundaries. But the education part is really how to expand this in a systematic way. That takes a lot of time and effort, and you can only do that after you yourself have a very kind of deep understanding of this field, of the what has happened and what is the fundamental of this field. And I don't think we're there yet. But the fact, I think, is also that we need significant amount of engineers, I think not just in the US, but across the world. And so there is a strong kind of urge to push the education to catch up with this demand. And another thing I wanted to add is obviously, I think at least one of the hopes in my mind for this to be possible is that we are not just relying on researchers or educators who are purely coming from computer science or machine learning or statistics background to teach this. And I myself actually come from a more engineering background, in wireless communications, some hardware, etc. And I went through the process of learning AI and machine learning myself. And I believe there are many professors who are coming from different fields, but they are all interested in AI now because first and foremost, AI is useful for many of the research projects that we are doing. But on the other hand, I think professors like myself and many others, we come from different backgrounds, so we kind of have maybe in a better position to combine AI with specific applications. Because I don't think it makes sense to just teach pure AI or pure machine learning, because many of the applications nowadays, many of the companies who hire data scientists here, who hire machine learning engineers, they want them to use machine learning to still solve specific engineering problems. So it's important to have this domain knowledge combined with the AI. And that's I think where, faculties who have both the background of the specific domain and the, machine learning and AI I think would be very helpful. And these faculties, the number of them are significantly larger, I think, than the ones who just, teach pure AI and machine learning.
Okay, thank you. And Professor Cao, so you come from a hardware engineering background as well. So what do you think about just the amount of people who can do the job, like in terms of like silicon design, like how do we get more people into this profession?
Well, I totally agree with what Professor Li and Shen mentioned about it has to all start from faculties who do research in this field, and then somehow they abstract it, they consolidate the knowledge to become a set of well-presented knowledge that to educate students. And I think from sort of the more application side, which is in my part is mechanical and aerospace engineering, I think besides the sort of the background foundational knowledge that build up AI, I think the application side, I think like our students will be more like users of AI, and the application side will need things like data sets for different application than just like looking at this image and then say this is cat or dog type of thing that's typical for benchmarks in computer science field. What we need is scenarios and application that's really drive home for students in our field. For example, in mechanical and aerospace engineering, the student passion in these majors is something that moves, right? Any movement will be of interest to the students, like a movement of objects, fruits, heat, and so forth. And so, for example, autonomous driving would be something that's very inspiring for students. And so what I'm trying to say is that I think what we would need to see is, for example, people in this type of field like myself, and to have more access to data that's beyond what currently prominent data sets and examples and benchmarks that's beyond the current that get into more applications in each different majors, like our majors and so forth. And that would be the penetration for AI into educations in our field. And I can see the penetration probably will start from classes like control theory, which already have a lot of like linear regression estimation type of thing. And that could certainly extend to include more AI type of algorithms. And then for our student projects, that definitely realization of product that has some smartness that requires AI would be very logical. And so that's what I see is needed is data set examples and scenarios and the hardware, like Arduino type of hardware that's very easily accessible, cost effective, and for education purpose, for realizations. Thank you.
Yeah. And talking about exciting case studies. So last week, America's Advanced Defense Research Agency, DARPA, ran a competition where they pit a professional fighter pilot against an AI system, 8 different AI systems actually, and one of them just won 5-0 every single time. So yeah, I think when you read headlines like that, you think like, wow, okay, this is an interesting, and these are interesting engineering problems they're solving. And, you know, like, so what happens to the fighter plane when you don't have to worry about a soft and squishy being inside, you know, like what kind of maneuvers you can do. It's all very, very interesting. Okay, we talked a little bit about the need for AI skills and the supply of AI skills. What do you guys think are the main challenges for educators implementing AI? You know, like when you teach, so like some of these AI-related disciplines, what's the number one problem you're facing? And if we can start with Professor Shen.
Oh yeah, sure. I have actually been teaching, as I mentioned before, like, you know, communication courses and some probably a little bit more theoretical courses. But for every one of them, I have been trying to incorporate AI and machine learning into part of the curriculum. And this is not only because some of the, as I said before, the newest development in these respective fields incorporate AI as part of the tool, but also because students who are, you know, taking my classes in this way would benefit from the added expertise in knowing how AI can impact this particular field. I'll give you an example. I taught a course on wireless communications last semester. This course historically has been a very standard course, I think over at least the last decade or so. We always teach the course the same way. There is standard textbook, which, you know, out of maybe hundreds of textbooks, kind of really stands out. And a lot of universities are using this standard textbook, and we teach following, you know, the chapters and etc. But over the last couple of years, we have seen that because of the research frontier of this field is moving with this new toolbox of AI and machine learning, a lot of new results and kind of a new techniques have emerged. And for some, you know, graduate level courses, this would give us an opportunity to incorporate AI and machine learning into the curriculum. And the difficulty really, from my experience, I've seen 2 difficulties. The first one is obviously, this is a new tool for most of the students that come from the engineering background. For example, they are more familiar with, let's say, C and C++ programming. They are more familiar with hardware, you know, programming, you know, type of techniques. And then when it comes to a massive amount of data, training neural networks, you know, optimizing over, for example, GPUs, things like that, they have not really had the fundamentals, you know, to do that. That's, I think, issue number one. For some of them, I have to basically start from the very basics, you know, like Python programming, you know, explaining how, you know, neural networks work. You know, a lot of things, you know, we have to basically teach them, especially in a hands-on fashion. The second is I think for many of the engineering materials, we're not just, you know, running, you know, deep neural networks on a GPU and getting, you know, as Professor Cao said, you know, ImageNet or typical classification results. We want to see machine learning and AI in my class. You know, we want to see how that affects communication performances. And then you have to develop new materials. You have to develop, you know, new projects, new materials to show that, you know, by doing this, it is better than the way that we have taught this course in the last 10 years. So how to design that new material is a challenge, because you not only want to show the cases where AI and machine learning give you better performance, but you also want to make sure that this is a deep result in the sense that the students understand that in this, for example, additional computation requirements, complexity, basically the whole picture. You have to teach them the whole picture. It's not just the research, again, just the research frontier. You have to teach them fundamentals. So these are the challenges I've seen so far in kind of, teaching AI related engineering courses.
Okay, thank you. Thank you, Professor Shen. And Professor Lee, yes, so the main number one challenge when you go into a classroom and you start teaching something that relates to AI.
Well, I think the challenges I have is similar to Professor Shen's talked about. In my case, I'm teaching mostly graduate students. So I've been teaching system and machine learning graduate seminar for the last 3 years. And this course is about teaching students how to build systems for machine learning. For example, how to design hardware accelerators, or how do you design the system software that runs on different type of hardware, such that you can make a machine learning, running machine learning applications fast. This is one part of the course. The other is how to apply machine learning methods to designing systems. For example, is it possible you use machine learning to solve problems that it's very difficult to solve in the past when you design systems. For example, one of the probably common problems is to design a cache bridging between fast access to slow access. Like if you typically have a storage system, or on the internet you have a content distribution network, typically to deliver this content fast from the storage system user or from the network to user, you have a cache sitting somewhere near the user. What to keep in the cache, what's not to keep in the cache? This has been studied for 5 decades. And now machine learning comes along now. I think that has transformed how we design systems in research. And therefore, there are new ideas how to design cache in a new way that can do substantially better than just using heuristics. Then similar type of things will happen in designing compiler, designing network protocol, and so on and so forth. So this is how to apply machine learning to a variety of system design problems. Right. I think, for example, Google Brain has made a lot of progress in this area, and academic community also are making a lot of progress in this area. So these are the 2 themes we have in the graduate seminar. And now next year, we're planning to turn this into a graduate course, which will have the challenge of probably half of the courses we need to lecture the materials like the students must learn, as opposed to just reading the latest research paper and discussing them. Probably will spend half of the time doing those things. I mean, the reason I describe this transition process is that no other university has a definitive way of doing this. So each party is experimenting how to do this, right? We are one of those 2. I think one of the big challenge, 2 challenges I feel that's worth mentioning. One is to teach students how to define a machine learning problem. It's often the case that once the problem is well defined, and then you can figure out how to design loss function, you can design, you can pick network architecture if you do deep learning, and you'll be able to probably solve that problem, how to build up the gold standard, how to, the training data set with knowledge base, how would you form that, and then just the programming how to do machine learning in some sense is the easier part. How to define the machine learning problem, I think, is more challenging, and how to build knowledge base is equally challenging. So those are the one challenge. How do we teach students to do all those things? Not just here's an algorithm, how do you do this? The second part is actually related to hardware. How do you set up the lab such that students can actually run their projects or homeworks without feeling their hardware is the bottleneck? I think currently, typically when you do teaching, you don't really use the research equipment. For example, if you have a research cluster of GPUs, you don't really want 100 undergrads, even 50 graduate students in graduate course to use it. So now we may probably have to go to the cloud. Amazon AWS, Google Cloud, or Microsoft Azure, or some other emerging places like a Cloud Lab and so on. But where do you get the credits to pay the students, to pay for this execution time? The bill can go up very quickly. So typically universities do not have a specific budget for this, or that much budget for this. So that has been challenging to me. For example, students could run their training on their laptop as the sort of homework 101, and to figure out how to use machine learning to recognize handwriting digits. And that's like a well-known machine learning 101 using deep learning approach. But when you start using ImageNet, even the mini ImageNet, a small subset ImageNet, and we're talking about training for days to do, one day. So the gap is gigantic, right? So where do you find the computing resources? How do you avoid students' frustration? I think that's one of the challenges here. So if you design a programming assignment or designing a project, you want the project to have a reasonable scale so the students feel like they're actually dealing with a reasonable size of data set, not just, a small data set with 10,000 objects. You want them to think about millions, right? But then do you have the resources to let them run things on millions of objects? Data sets with a million objects. I think that's, this has been a challenging issue. Even a rich university like Princeton, this is still an issue.
It's interesting, yeah, because okay, you're a student, but you need this, just like machine worth 5 to 10 million just to test out your theories. I mean, the cost of entry is quite high into the field. All right, we'll probably come to our next and final question, and this one will probably start with Professor Cao. The relationship between hardware makers, AI software companies, and AI educators. Do you think there's enough cooperation going on? And how can private companies, help the academia?
Yes, of course. First, I'd like to echo what Professor Shen and Lee mentioned in the previous question about what's the challenge for education. And that probably leads to sort of how companies can collaborate with educators in these aspects. And so like what Professor Lee said, problem formulation and setting up project labs is a main challenge, right? And actually, and I think that's crossed all, sort of engineering majors. And as our education move toward from very specific topics, subject topics, to more complicated, or not necessarily complicated, but topic that require cross-disciplinary type of integrations. And that become more and more challenging. And so that probably, so probably the requirement would be more like a cross-majors type of collaboration among colleagues. Like I'm going to learn AI from my colleagues in computer science, and then we will set up some particular domain-specific applications for student education, and company can come in to help. And so since I haven't had this kind of experience, so what I'm saying is more like a wish list, right? So I'm saying that sort of repeating what I said before, that I think from our application point of view, mechanical and aerospace engineering, there's a lack of data sets for instructions that's relevant to our fields. For example, if the example could be like identifying manufacturing defects, then facial detection, that would be very helpful. There's a lack of benchmark and prototype type of AI examples for our education. I can see our education involve two types of problem. One is to solve inverse problem of a very complex mapping. For example, nonlinear fluid flows or heat transfers or structures, which may have well-developed forward model, for example, numerical algorithm or finite elements, but to find the inverse is very difficult, right? And that's where AI can come in, and that if we have those kind of example, that would be very useful for how to motivate students and to show how AI is applied to computation. And I call it computational AI. And then go to like setting up project labs. That would be more like experiential AI. And I see this is, and so the previous computational AI, I already see a company can come in to help collect data sets or coordinate among educators, collect data sets and example problems, not many, but become prominent example for each different major fields, different majors. And then for the more application side, lack of low cost and easy to realize and integrate type of embedded controller that involve AI. Like I said, sort of like Arduino type of thing for robotic type of projects would be very helpful. But in addition to that, to realize that requires software tools. And so I don't know if there's, probably not, but there's a need of software tools that include AI for top-down type of system analysis, design, and simulation. So for example, in our programming class, we usually start with bottom-up type of programming. But then when we get to the senior level capstone design project, we teach them more like a top-down application software, like graphic-based rather than text-based. So it's based on the top requirement and then flow down to each nuts and bolts. And then the sort of different tool comes in. And I think the tool that those kind of top-down type of tool that would include AI, because top-down type of tool in our area is already very complete, a lot of components, but it lacks AI components. And so having AI as part of this would definitely become a very powerful engineering solution tools that's used for later part of student educations after they do this sort of bottom-up nuts and bolts type of text-based programming. And so that's sort of my wish list, that cross-major collaborations and sort of create software, hardware examples, and that would be sort of closer to our application would be very much needed. And I definitely see how company would be contributing in this area, as I've seen some announcement of product that's sort of moving to these directions.
Mm-hmm. Okay, and if we can have just sort of like really, I'm sorry, gentlemen, short answers. Yes, so cooperation between AI educators, AI companies, hardware makers, like possibly governments. Like, what do we do to make it happen? If we could, yeah, Professor Shen, please.
Yeah, I think one thing that is, I think, quite unique about the AI education is that there is obviously a need for a significant amount of data. This is something that educators alone I think this has been kind of mentioned by Professor Lee before. We cannot really have that. We cannot create that in a small scaled class, in each university. So this is a part that I think relying on industry university collaboration really makes sense. The other part, obviously, is also in the AI field, the tools are evolving really, really quickly. When I say tools, I mean both hardware and software tools. So universities, again, cannot just rely on some standard tools for many years to come. They have to basically adjust based on what the field, where the field is moving to, because at the end of the day, the students we are educating are the ones that will be contributing to the workforce of these companies. So it's better for them to be trained with the tools that are state of the art. So I think these two fields are really the ones that we, at least in my mind, need collaboration the most from companies. And in the meantime, I think the companies also benefit from such collaboration because as I said, we grow the workforce. I think it's better for everybody that's involved in this business. So.
Yeah, absolutely. It's just like it's part of every technological cycle, like you equip the researchers with the latest and greatest, and you're gonna harness the benefits for years to come. And I think something similar happened in storage, Professor Lee. So yes, what would you want to see? What kind of participation would you want to see from the private sector and from the people who know, design commercial silicon?
I think from hardware vendors' companies' perspective, I think they like to make products that people can use. From educators' perspective, I think we want students to learn how to make this new generation hardware. I think that's where the producer-consumer type of relationship, right? So as Professor Shen mentioned, I think it would be helpful if there's more sharing going on. I think that one of the challenges in educating students to figure out how to design hardware is that there's no convenient hardware environment for them to run a real project. For example, if you want them to program a field programmable logic array, like FPGA, gate array, then there's no there's not enough higher level tool for students to program, to design their idea that make them work very easily, right? So I think even designing software stack or the system software stack and try to modify them, I think it's also new thing because that's a moving target. So even though there are many open source systems, they're all quite complex. Like if you want to modify TensorFlow software stack or PyTorch software stack, it's quite involved. It's not like students can figure out how to do within a week or two. So what you want is that students can do things in a week or two and actually make progress. They can see a baby system from beginning to work. I think, when I back then just do a contrast or some kind of comparison. When I was teaching computer architecture course, I was able to develop, for example, 9 small projects, one after the other, one built on top of the other. In the end, student would have a processor, a general purpose processor, but very simple processor, and running with a CAD tool like a Cadence or some other CAD tool. They can actually run, and they can run assembly language program on the processor they actually designed. And this can be done in one semester. We don't have something similar to this, right? Even, for example, when I was teaching operating system course, we have 6 project series, from building a bootloader and to actually building, virtual memory system that run user kernel mode and a simple file system. So students at the end can run a game on their OS and running on the Intel processor. So this can be done in one semester also. We don't have anything close to this for machine learning. And that's a challenge. So if your company could, inside the company, each company has their development tool chain, right? And typically they're not really sharing the tool chain with the universities yet. They're not open source it because they worry about competition and so on and so forth. I think if they're more open type of tool chain for educators to use, actually close to real, students can see from the beginning of design something to the end actually something work. I think that would be very satisfying for students. And also very good for companies to see such students. For example, back then when I was teaching OS course, students were able to design OS from the beginning to actually have something running. Those students are highly demanded in the Silicon Valley because they can answer all kinds of questions you come up with about OS because they have done from the beginning to something, even as a toy, right? I think that we want students to be able to do that if you design hardware.
Okay. Well, yep, certainly. If any, like AI software, hardware vendors are listening, there's the space for an open source kind of developer stack that could be easily demonstratable to students. But I'm afraid this is everything we have time for today. So many thanks to all of our participants. Thank you for sharing, like your learning from a lifetime of learning. Thanks, Kneron, for hosting this meeting. And if you want to find out more about sort of like the latest about on AI in business, go visit aibusiness.com. But thank you for watching.
Thank you.
Thank you.
Well, I don't know about you, but I certainly learned a lot from their discussion. It's interesting to understand that even the most renowned universities in the world are looking for solutions that can allow students to access the right tools to support a curriculum that is so new, so fluid, and yet vital for the future. So let's hear what educators in Asia have to say about the subject and see if there are any differences in what they see as we catch up with Professor Frank Zhang from UCLA, who is in fact also a co-founder of Kneron, Professor Jiayan Li of the Taiwan National University, and Professor Tsing of National Tsinghua University. The panel was moderated by Maggie Tsai from Taiwan's public television service.
Yeah, let me introduce myself. My name is Frank Chang. I now is returning to UCLA as a faculty, but in the last 4 years, I took a leave of absence and returned to Taiwan as the president of the National Jiao Tong University. Yeah. Mm-hmm. Yeah. In the last 20-some years, mostly I'm doing the chip design research. And as you know, the co-founder or the founder, the Junchen, yeah, Liu actually graduated from my lab, UCLA. Yeah. Although we are doing the chip design, we don't limit ourselves in terms of designing anything interesting. So all the way from the baseband to the RF front end, from the intelligence system to spectrometer for space. Yeah, that's what we were doing. Yeah, thank you for inviting me.
Thank you, Professor Frank. And maybe next we have Professor Ho.
Yeah, okay. Yeah, good morning, everyone. I think I say good morning because I think everyone is in the Asia time. And yeah, my name is Zhong Ho. I'm currently a professor in National Tsinghua University, yeah, in computer science. And my background actually is related to research on design automation for electronics. But recently, my students also working on the AI, so I actually offer a class on medical image, using the deep learning. And also in my background for design automation, we also apply the design automation optimizations for this neural process. Yeah, and also neuromorphic computing and accelerator. Yeah, so I think I think I'm related to the both software and hardware side. Okay, thank you. Thank you for inviting me.
Thank you, Professor He. And next we have Jiayan Li, Professor Li from NTU.
Yeah, hi everybody. My name is Jiayan Li. I'm from the Department of Information Management, National Taiwan University. And my background is more close to the industrial engineering. So I'm doing something in the machine learning, AI, or data science in the manufacturing system. Okay, so focus on some intelligent manufacturing or something right now we say the industry 4.0. So we are trying to build out some project to improve the manufacturing system by AI technique. So doing something like related to the demand forecast, pricing forecast, predict maintenance or supply chain optimization and so on. So I think I'm very happy to join this panel discussion. Thank you for inviting me.
Thank you, Professor Lee. And me, myself, I'm Maggie, and I have a degree in journalism from Columbia University, and now I'm a news anchor here in Taiwan. So it's my honor today to be the moderator for this Asia Education panel. So now we start from our first section, which is how AI is changing in the future jobs. So first, the first question we would like to throw is how will AI impact the jobs of the future? Professor Chen, can you share your insights with us first?
Well, AI actually impact every individual fields, into the future. I would say, without any knowledge about the artificial intelligence, it would be very difficult for any young people, to conduct basically in all fields, all the way, from the science, technology, into even to your major, journalism. It would be very difficult without the knowledge about the artificial intelligence. Yeah, it would be very difficult. So therefore, I think that this is some kind of basic knowledge and the basic tools that all students should learn. When I was in the National Chiao Tung University, I particularly request all departments, including English majors, to learn how to program. But right now, I think the university also add additional AI requirement to all students in all departments.
Right. Professor He, if anything to
Yeah, I want to echo, yes, I want to echo what Professor Zhang mentioned. I think right now AI is a request. I think it's a required skill for everyone. So in our university, we provide a AI program for everyone. In the past, the AI program actually is only for the people working on the computer science or the electrical. The program actually is open for everyone, or even for undergraduate students.
Right.
So every undergraduate student, they can sign up the AI program, and they can take the course of the AI related core in the application level class. Yeah. So I think the student will learn, and this is the need for every student. So of course, I think AI, of course, impact for everyone. So we need a student to, from different discipline to know the background of AI and try to find an application, try to help the AI application for every discipline. Yeah, this is from my side. Yeah.
Right. And Professor Lee?
Okay, thank you. So I think the AI impacts the job in the future, just like something right now in the manufacturing system. For example, some routine job or redundant tedious job. And for example, we have the quality inspection. So in the quality inspection, maybe the human need to use his eye to inspect the product quality. However, right now we can introduce something, the deep learning or AI technique to enhance this or replace this process. For example, building the automatic optical inspection, AOI system. So there are some AI technique that may replace or some routine job about the human, but there are some new job that may be coming up. For example, we have the data scientist. Okay, we have the robot trainer because we need to train the robotics or robots. Okay, and then let them know how to, we need to control and teach the robot to handle each kind of different jobs. And also we have the data labeling operator. Okay, so that's kind of, they need to operate the many, label and for the, the machine to learn this data set. So I think that there are some jobs maybe will come in the future. So AI indeed impact this area.
Right. And so the next question would be, is our current education system well equipped to help students, to really meet the needs of the future AI-driven economy? And I think some of you have experience in teaching abroad in US and also in Taiwan. So maybe share your experience from different nations of their education system. Professor Chen.
Well, in terms of AI research, I've been doing that for the last almost a decade. But in terms of the teaching and the education, that's really challenging to all of us, actually. Yeah, because has a different several levels of the education that we can talk about. For example, for teenagers, that's one level. For college students, that's a different level. Yeah, for graduate students, that's a different level, and for professionals, that's another level.
Right.
Different levels, I would anticipate it's a different methodology and the different course materials, and even any of the, well, to most people maybe offline the learning is enough, but for lots of the graduate student or more advanced, even for the college student, it would be fun to use something offline, something you can program and you can enjoy seeing the outcomes, from the to wherever the environment may be. So in that case, I think that something is important, like Kneron is doing, to share some of the design inside, both hardware and the software co-design the platforms to invite the people, even teenagers that could leverage it, to do something fun if they do have workshops, parents involved, the activities, even summer camp, and the college, if there is a platform that the student could actually aim for some of the applications to get their attention, something like a face recognition or something, for the car racing, that's a very top, popular the college activities. And for the graduate student, of course, that is all important. If you have the offline, the ecosystem that include all models of the AI, all the softwares that can be used, open source that can be implemented, and to the research, of course, that is also necessary, for all levels. But we do need a different strategy for different level of educations.
Right. Professor Ho?
Yes, I can talk about from the university side. Yeah, and so as I mentioned, we already have the so-called AI program in our university, and it's a two sub-programs. One is teaching AI core technology, so like statistics, data science, and so on. Some mathematical class, and then because I think in the past we only teach for basic knowledge for students, in university. But right now with the AI, I would say that based on in the paradigm of the AI, I think we need to apply the core technology for more on an application. So for some class, I think right now we have some class related to medical image, and also the sports science. So we cannot just teach the core course for AI. We also need to apply this knowledge for some dedicated applications. So right now, I think inside university, I think we are facing some challenges because we cannot just teach the tradition I think how we taught in the past maybe 20 or 30 years. Right now, the teaching way should be changed. So right now some professors, they are using the free classroom. Everyone right now they can learn online. They can read the slide and they can read the video, then do the Q&A. And another way is that we can do some dedicated projects, as I mentioned, medical image, sports science. So I think that's a good way to do the AI class in the future. Yeah.
Right. Professor and students have to learn together nowadays, right? And Professor Lee, what are some of your thoughts?
Yeah, well, I believe current education system may partially help students to meet the needs for AI. For example, we build a lot of the programs, no matter these AI programs in engineering or in the business college or in the medicine college. But there's a gap still, we need to improve, or there's a room there. I mean, when we learn something, we learn a computer science skill, or when we learn a mathematical theory or the statistical theory, we can learn these things from the courses. Okay, so that's totally no problem. However, when a student after then graduate, they still join they need to join the industry. Okay, no matter they join the manufacturing industry or the bioinformatics industry. But right now there's a problem is about the domain knowledge, because we don't have the domain knowledge. So when we want to apply this AI technique, but we don't know how to find the best, using the best approach to solve the right problem in our society. So I think we still need to try to fill the gap based on our education system. We need to also teach the student about some experience or focus on some domain knowledge. Okay, so we can fill this gap later. Okay.
Right. So all of you have posted some. Yes, Professor Chen.
Yeah, that's a good point. Actually, always is on the both sides. The fundamental knowledge, the capability in the executing the AI, the programming, and the system development. But on the other hand, most important is domain knowledge, right? So maybe some kind of forum, online forum that could be built, especially through the universities, and to bring the domain knowledge person, with the AI interested group. Yeah, that could actually do a lot. I think. Yeah. For example, AI is about the daily life. But on the other hand, some of the daily life is sophisticated, right? It can be a manufacturing, it could be the hospital, that could be other things. But all of them requires a lot of the domain knowledge. Actually, people are doing that for their life, but they see the problems and solve the problem and unmet needs. But on the other hand, those people has the capability in conducting the AI algorithm and the programming, but they need to find the unmet needs, the real life unmet needs. Yeah, unless these two that could be engaged, then it's hard to really to make an impact. Yeah, when you need an impact, you need both sides. That's the complete story. Thank you.
Right.
Yeah, I also agree. Yes, but I think but right now I also found something. I think in currently some students they try to apply AI for some different domain. I think that's good, and that's related to some application. But I'm kind of worried about this because right now, sometimes this work is more related to engineering work. You know, you need to tune the parameter. Of course, you need to know the target domain. So because I'm in computer science department, so we still require some student to work on the core machine learning or AI technology. You know, you cannot just work on the pure application side. So I think this is also the challenges we are facing now, because some students think they probably think, oh, if I can write some TensorFlow, you know, write some high-level programming, then I'm an AI expert. Actually, I would say maybe that's way too far. I think they still need to know the detail about how to implement the AI, because the AI, you know, for currently AI, for the deep learning technologies, most of them are still lies in black box, you know.
Yes. So all of you have posted some challenges in this from your education experiences. So what are nowadays the most popular approaches in AI programming for students to learn from your observations? Professor Chen.
Oh, you mean the difficulties in terms of learning?
Yes, like so now you also have teaching experiences in UCLA and also in Georgetown University. So have you seen differences in different nations as students learning AI programming?
Well, there may be some differences, but most commonly, well, in order to master the fundamentals of the AI knowledge, I think still some of the basics, mathematics, statistics, even on the other hand, some of the physics that actually need to be understood. You cannot just out of a blue, you know, just generate something, some kind of algorithm which can be maybe useful, but without these fundamental knowledge. Typically, I think some of the fundamentals actually the Taiwanese students actually quite good, you know, especially with good universities. Yeah. But on the other hand, most US students are more capable in coding. Yeah, I find the US students are much better actually in that regard. Well, it's just because of the different education systems, you know, there are different objectives, you know, over their period of the time when they grow up. Yeah. So each has their strengths and weakness. Maybe fun. We can group both sides, you know, take advantage of the strengths of the both and avoid the weakness of that. That is another possibility. Maybe we can team the UCLA with NTU or Tsinghua or Jiaotong, you know, that may be fun.
Yeah, and Professor Ho mentioned students are learning AI by themselves sometimes. So what are some of the most popular programs nowadays, like students use to learn it?
Yeah, it also depends, you know, for the student with some background or without background. So without background, I think, you know, I think not in our university, I think in most of universities, right now, if the course name called it deep learning, machine learning, introduction to deep learning, introduction to machine learning, and strong, they will attract many students to sign up. Yeah, but for some advanced class, for example, I actually offer a medical imaging class last semester. Yeah, so for my class is actually for graduate students. So right now, as I mentioned, right now students can learn the basic of AI technology very quick online. You know, in Taiwan, we actually have two famous YouTuber. Actually, they are also the professors. I think yeah, both are from National Taiwan University. One is the Professor Li Hongyi, another one is Professor Lin Xuantian. I think they are both from the National Taiwan University. And also in our university, we have one professor called Wu Sanghong. Yeah, he also recorded the deep learning class and also received the grant from the Google. Yeah, so I think students right now, they can learn this very quickly. They can learn this at home, but as I mentioned, they need to learn the different aspect. I think the Professor Lee also mentioned in different target domain. So for medical image, we actually invite the medical doctor to the class to share what kinds of problem they are facing now, what kind of the challenge they are facing now, and students will learn this. Then student for programming, I think student can learn the so-called the TensorFlow or the PyTorch. Recently these two languages are commonly used programming language for AI, but it turns out they need to when they apply the certain application, they still need to find out the existing code, because right now I think Professor Zhang also mentioned many research actually right now they're open source. So students can find a model and the code online. Then they need to apply. They need to do something called the transfer learning. They need to. So I think right now the students they are facing is related to how to apply this existing model for solving their target problem, and then they do tune the result. If they cannot tune the result so good, then they will read the paper. Then they will know what they lack for what's the deficiency for this problem. Yeah, this is my 2 cents. Yeah.
Right. And Professor Lee, have anything to add up?
Yeah, I echo the Professor Zhang and Professor Ho's points. I believe the AI or the deep learning or the CNN RNN models, and the student can learn very quickly from the open sources or online. But I also would like to point out about the fundamental technique or fundamental courses. For example, just like the calculus. Calculus is so important and its impact to the development of the deep learning model. For example, we may learn the deep learning, but at the same time, we know that deep learning needs some optimization approach. For example, they need to calculate the gradient or using the stochastic gradient descent approach to find the optimal solution to update the weight training in the network system. But all these optimization approach, the fundamental is from the, for example, calculus, this kind of the courses. Okay. For example, the other one is statistics. Statistics is also very important because sometimes we may not have the big data. Okay, sometimes we only have the small data system. So how to use the small data set to influence the population, okay, or to influence the something I want to get about the whole view. So in that situation, statistics is really important to give the guideline to the, our AI or machine learning when we don't have the big data set. Okay. So I think our fundamental courses is also very critical and also popular in our university system. Thank you.
Right, thank you.
I want to add something, sorry. Yeah, I totally agree with what Professor Lee mentioned, but I think in the past, if we teach this core course, students will not appreciate this. They did not know what they can use this technology for certain application. So, but right now in this AI era, I think students can learn this high-level technique, high-level program very quick, but soon they will face the war. They will know if they don't know this core technology, statistical, gradient, descent, and even operational research courses. They will not move on. They cannot simply tune the parameter, hyperparameter to achieve their task. Yeah. So right now it's like we let the student quickly get into this application, target application, but soon they will learn that they actually lack many things. Then they will go back to take this course. Yeah, I think this is why I found in our university.
Right, but it's an opportunity right now. Students may think that some of the fundamental courses are kind of boring. Yeah, but right now because they find the incentive, in order to carry on some of the high level of the AI tasks, they find that they actually have to go back and learn the depths in the fundamentals, and it's our opportunity as a faculty really to group the a domain of the knowledge right and get them excited. I think without the passion, there's nothing can be achieved. Yeah, fundamentally, is all things start from the passion. Yeah, I think in the past, our education system more aim on so-called degree oriented. You know, students come to school mainly is for the degree. Yeah, so they can go to TSMC or MediaTek or somewhere else. You know, Google maybe. Yeah, but not really from their passion. But this is a time because of the AI could do so many fascinating things. You know, at some the impossibly imagined the level from the past. We do get the youngest's attention. So this is a time to come back to re-wrap up and very persuasively, you know, convince them. So this is the time you have to go back to some of the basics that you must be tortured in order to learn. You know, but you to gain a value, to gain a price once you master the things. So it's a golden opportunity.
Right. So now I'm interested, if say I'm a passionate student who sign up each of your AI classes, what are some projects in AI programming that I will get from your courses? Maybe each of you can share something. Professor Chen first.
Well, to me, I always ask the student questions. You know, what are their interests? You know, the different people from a different generation has a different interest. You know? Yeah, so I think it's important to build this interest, the passion, as I said, and to move on the creativity. I think actually today the young people, they're more creative than the parents' generation. Maybe I'm at the grandparents' level at this point. Yeah, but without the creativity, then we lost the total the meaning of the AI education or AI research or development. Yeah, so we need to essentially to have them to find that this is fun and this is actually has an impact. You know, and with educators help, with the companies help like Kneron, offer some of the easy use, even many times under offline conditions. I think that will stir more interest, and
Right.
it's
Yes. So I want to add in a question that is some of the AI program projects, what are some of the ways you will incorporate products such as the Kneron AI USB dongle into your teachings also? So Professor Ho, can you share some of your experiences with us?
As I mentioned, if we are talking about multidiscipline AI application, so right now students need to do the fast video recognition, computer vision, and to recognize something and try to do some collect some parameter to help them to do different applications. For example, in our medical, not medical, in the mechanical engineering, students from mechanical engineering, they need to know how to improve their and then they need to do some. They still need to catch the image. So in the past, they need to purchase a very expensive camera, and they need to do a lot of image processing for these things. But right now, I think with the product of Kneron, I think it's a KL 720.
720, yes.
Yeah. This USB disk. I think that's this lightweight USB things. I think they can help. This dongle can help students to avoid this burden for doing such kind of implementation, so they can embrace the advantage from AI. So I think that's good for the students who are in different multidiscipline and try to use the solution of AI. I think that's quite good. Yeah, so they can learn this. They can use it very, very quickly. Yeah.
Professor Lee?
Yes, since I teach some courses related to the intelligent manufacturing system or manufacturing data science courses in our graduate students. So their project is very related to the, for example, capacity planning, demand forecast, price forecast, or some feature selection, or how to identify the root cause for the troubleshooting, or sometimes they do the production scheduling, supply chain optimization, and the predictive maintenance, and so on. So this type of the AI product or device, actually, it's very helpful. For example, when a student doing the product quality inspection or the defect inspection, they sometimes need to use the deep learning and to do the image recognition, right? So they need some AI product accelerator to enhance their calculation power. Okay. Otherwise, they just need to connect to our computer center and using some more powerful, but sometimes the bandwidth is not enough. Okay. So that's the reason why I think all these AI device, just like the AR, VR, I mean the augmented or the virtual reality, this kind of device is also helpful for the student to learn. For example, in manufacturing system for the machine, if it is shut down, how to find the critical point or root cause, and to one by one to follow the SOP, I mean standard operating procedure, and to recover or to repair the machine using this new smart AI device. I think all this is helpful in the education courses or system. Thank you.
Right. So from your perspective, how do you think like hardware makers and AI companies can come in to help in this AI education field, especially like companies like Kneron? What are your expectations and your thought that they can do something helpful in the education curriculum? Professor Chen?
Well, I think an AI company that should build something easy to use and low cost and low power, for the individual students. It cannot expect the people to use a 40-watt device, and the offline all the time, Yeah, the offline, I mean, online all the time, that kind of use will be not realistic. Yeah. So then I think they provide some of the rich learning materials, including some of the open source codes, some of the reference models, some demo, the videos that make AI learning much more easier and more fun. I think that is important to get their passion up, to get their interest up, and to get them, more willing to get deep into the fundamentals, learn the necessary coding and fundamental mathematics and the physics, in the ultimate way. I think that would be the most important impact. Yeah, but the AI company, on the other hand, they should help the school. Should help the community centers for some of the activity students, summer camp, the host maybe offline events, workshops and hackathon. Hackathon that usually stimulate a lot of excitement and interest. And for learners and all these, I think the company do have the responsibility, to help.
Yes, and Professor Ho, what are your thoughts?
Yeah, I think I totally agree with what Professor Chen mentioned. I think, this is for I think he already mentioned most I would like to say, but I want to point out something. So now, as I mentioned, we have Kneron, this USB bundle for this AI acceleration. I think this is for this newcomers for AI courses. Yeah, they can use this for different applications, as I mentioned, the computer vision, speech recognition, and so on. But for some students, especially in our department, some students actually working on this hardware architecture, about the circuit design, system design. So they would like to know what's the current state of the art for this AI acceleration. We actually read a lot of paper from the ISCC, DEC, and also some newly papers from archive, but we would like to know what's the company solutions. So if Kneron can provide some, the internship or even for some project with the professors, I think the student can learn from from the more practical side, and they will help the company, and the company actually can leverage the resource and the knowledge from from students, professors in universities. Yep.
Right. And Professor Lee?
For the hardware maker, for support AI education, please design a machine to help me to grading the exam, students' exam. I really need this kind of the device. Okay.
That's right.
Yeah. Sometimes the grading is, but from the other side is I think the device sometimes is for example, right now we mentioned about the edge AI. I mean, sometimes we collect data set, but not necessarily. Not necessarily we need to upload our data set to the cloud, to the or to the backend system for powerful calculation. If we can handle some simple issue or just use the small data set and then can give the quick response to answer the question in the end point, that may be better. That's the reason why we call the edge AI. So sometimes the AI device, if they are designed for this purpose, I think it's useful. The other side is when we design something, one thing is about the 0 to 1. I mean, we just build out some new product or new technology. But sometimes we also need to consider from 1 to N. I mean, sometimes we need this product is the market oriented, or sometimes we hope this device can scalable. I mean, this device can use in the small data set or small scale problem, but this device can also help us to handle the large data set or a large scale problem. So I think it's also useful for the student, because sometimes the student, they collect data set. Sometimes it's very small data set, but sometimes they're collect data set diverse and non-structured. Okay, the data set come from everywhere from the open sources. So I think the more generalized sometimes is also useful. I mean, this device, if we design, can be generalized a little bit or scalable. Sometimes it's also helpful to the students' education. Thank you.
Yes. Okay. As our times are wrapping up, any of you would love to add any last notes on AI education, and especially with Kneron's product? Yes, anyone? Or last words of your expectations in AI education?
Well, of course, from the circuit design, the chip design point of view, I also like all my students, future students, really, in the classical circuit design, analog way or digital ways, none of them are actually the perfect, because most of them are the event specific. It's hard to be reconfigurable and be flexible to in facing the different situations, different instances, especially. Yeah, but I do think AI is the most powerful tool that the student for SoC, the system on chip designer, to learn, to master, and to really think how to implement into the circuit architectures. That is a way I think Taiwan is already strong, but need to be re-emphasized in their the education and in their practice into the future. Yeah, I think that is maybe something, especially in my own profession, that I would like to see. Yeah, but it takes time. Yeah.
Right. Okay.
So for me, I think, I think right now AI is booming. So students are taking classes for AI, and they will need to practice the AI programming for their application. So, but not every student. I think student currently university work hard for some donations for the equipments. For example, like the high performance computer and some video cards, for accelerating some GPU for accelerating the AI application. But not every student right now can receive this computing resource. Okay, so student, if the rich student, they can purchase this equipment. But some students they probably need to sign up, use the resource from the in Taiwan, we have a national high performance computing center. So we can register account, and then we can use the resource there, but it's still costly. Yeah. And so with the product of Kneron, I think with this USB AI accelerator, I think the students can practice it very quick. Yeah, practice their programming and the result very quickly, and also they don't need to worry about the loss of data. I think this is on the other side. So right now, the people are worrying about something called the machine learning as a service. That people that send out the data to the cloud for training, and they're afraid that the data will be, lost somewhere. But if you can do the edge and just close to your computer, then you don't need to worry about the loss of your. Some people will steal your data. So I think that's a very good business model for Kneron. So I would love to see the future for this product.
That's a good point.
So the last notes for me, I think it should be, mathematics and the domain knowledge are critical. Okay, that's all.
Okay, thank you. Thank all of you for your precious time and your insights. And thank you for joining the Kneron education panel. We're excited to look forward to your future projects.
Yeah. Okay. Thank you.
Thank you for your
moderation. Yeah.
It was certainly very interesting to hear how many similarities rather than differences there exist in teaching AI in university classrooms across different regions. One thing that really popped out to me, though, was Professor Chang's stress on initiating the rising generation's preparedness for future jobs through extracurriculars such as summer camps to spur AI coding in younger students, and the point of making it fun and inspiring, or perhaps even integrating in play. And as for our last panel today, we turn to solutions providers from Europe and the Americas as we chat with founders Geert van Nuenen of Teraki, Mario Murillo of Solutions for IoT, and Nicola Andelic from MyVoice, moderated by myself. Okay, hello everyone. My name is Charlene. I'm a marketing analyst at Kneron. I'm very proud to be moderating the solutions provider panel as we're joined by some of the brightest minds in the industry pioneering the future of AI adoption in consumer and enterprise spaces. Today joining me are Geert Jan van Nuenen, CCO of Teraki, an edge AI solutions provider company whose mission is to enable personalized and accurate machine learning-based applications without a compromise towards 100% safety. On the other hand, we also have Nicola, Nicola is the co-founder of MyVoice, an AI company whose mission is to unlock the power of voice using the latest machine learning technologies. And we also have Mario Murillo, founder of Solutions for IoT, an edge AI solutions provider company that is committed to build a better world by transforming companies with the correct application of IoT. So, gentlemen, could you please tell us a bit about what you do and how edge AI is connected? And to begin, I want to start with Mario. Could you please talk a bit about how do you leverage edge AI to build in concert with the cloud?
Yeah, so basically we are building solutions for our customers so that they can make better solutions with smart information. So we have been building a platform that sends and monitors like health, smart lighting solutions to better make decisions on energy savings, and that's one way that our solutions are helping deploy IoT in LATAM at the moment.
Thank you, Mario. Would you want to go a bit deeper into how edge interacts with cloud in this case, however?
Yeah, so basically our solution gathers information on the energy consumption, location, and sends the data to the cloud, and in the cloud, it makes excuse my English and train of thought here, but basically I'm a little nervous. I've never done this over the Zoom call, but basically,
yeah, it's fresh for everyone.
So in the cloud, we have a platform where the data gets stored, and basically it gets programmed to be able to either turn off the lighting, smart lighting in public smart lighting, for example, and also gathers information about high peak voltages, and if there is a lighting that is not working, it gives alarms, sends alarms to the proper department so that they can make the proper arrangements to fix the lighting and so on. So basically, that's the solutions that we are making at the moment.
Okay, thank you, Mario, for the intro. Jared, would you also like to chime in a little bit on how you leverage AGI to build in concert with the cloud?
Yes, of course, Celine. Thanks. Yeah, we in Teraki actually we work both at the edge and at the cloud. We have software for edge and cloud, and what we in essence do is select relevant information from sensors. So we target the automotive, robot, and drone markets, vehicles or things that are equipped with a lot of sensors, such as cameras, IMU, LiDAR, radar, and these sensors produce a lot of information. And what we do for our customers is actually to, in that stream of information, that stream of data, to select the very important and relevant either objects or events that they require to train a certain AI model, so to do machine learning in the cloud. So what we actually do is productize AI pipeline, bridging edge and cloud for the customers to configure what and how they would like to train a specific machine learning model in the cloud. And by doing this smart and efficient ingestion of edge information, we make this process very fast but also enable our customers to improve the reliability of their machine models, as we've productized this in an automatic learning loop. And finally, on the edge side, we have a very tiny piece of software that actually operates on low energy, low CPU, low RAM at the edge.
I see, Gert. So it really is the edge features that allow this efficiency to happen, to cherry pick the data that is needed. Is that what I'm getting here?
Exactly, because if you train a model, and particularly for autonomous driving, you need to collect huge amounts of video data or LiDAR data in order to get a reliable model. And this entire process we speed up by doing it more efficiently, but moreover, more intelligently.
Thank you, Gert, for your input. That's very interesting, and it certainly is something that's very needed at this point. We have this data being a big explosion everywhere. And this said, moving on forth to Nicola, would you please talk a bit on also how MyVoice is leveraging edge AI and cloud?
Absolutely, yeah. So my name is Nicola. I'm one of the co-founders of MyVoice AI. And just to give you a little bit of introduction of what we are doing, we are taking voice and basically adding a human biometric factor to it. So basically what we do, we recognize people in any language, dialect or grammar via voice. And it's usually in the world, it's called biometric technology. And we believe this will unlock quite a lot of possibilities, both in the edge and AI. So the way we make both work is that, as the gentlemen before explained, machine learning models require a lot of data and a lot of data to process it. So goes for the human voice. The way we are doing that and to improve it, we have a hybrid model where we are learning the model on the edge and sending the derived learnings from that model at the edge up to the cloud to improve the overall world model. I think if you go on Google, you will find out a term for this called federated learning, which means if you have, for example, 100,000 people around the globe using biometric technology to recognize, to do payments or access control, we learn of each individual model, we send it to the world model up there anonymously, and then we can send the derived learnings to all of the model. So it's pretty important for us to be able to learn from individual use cases, from all individuals around the world to improve this to be as accurate as possible.
Thank you, Nicola. And I think the point you mentioned actually leads me to think about data privacy issues, because right now there's a lot of anxiousness about data being sent to the cloud. But you were saying that you're able to have all the information being processed on the device and only the final inference go to cloud. Is that right?
That's correct, and I would actually like to kind of elaborate on that. So this is kind of to explain the question about how do they work together, and this is for the big corporation, for banks, financial institutions. But where we are actually moving with all of this, I think all the AI, all the neural network acceleration eventually will happen at the edge. And to be able to do that, you need to have enough power. Processing the chips needs to be able to accelerate neural networks, and kind of one of our biggest reasons that why we are seeing growth in the semiconductor space is that we can do the biometric authentication of the human voice at the edge. And this is the stuff, I'm sure you at Kneron, you're working a lot with access control. You already are familiar with face. We believe this should be done together at the edge and never actually leave the edge. So this is why we believe that privacy is very important. And in terms of voice biometric, a solution from MyVoice is we never store any voice files. We only store the derived learnings of the machine learning models. And this actually gives us quite a lot of good traction, especially in Europe, where privacy is super important.
Yes. Thank you, Nicola. I see that our other panelists also want to chime in a bit. Do we want to start with Geert?
Yes, Charlene. At Teraki, what we do is very similar to what Nicola just said. Our end goal is to have these algorithms run at the edge. So we allow our customers to ingest the data, train the models in the cloud, but then push them back to the edge where they can run in a very efficient way, very accurately. And so whether it's mood detection, face detection, lane departure, traffic light detection, or any other robot or automotive use case, at the end of the day, it should run in the car for multiple reasons. It's for speed, latency, and you cannot rely on network transmission for safety-related functions. It's for cost, for economics, but also, as you rightly, and Nicola rightly pointed towards, for privacy. So it never leaves the car or the device where it's used.
I see. So that seems to be the general direction we're going forth with, moving to the edge. Everything happens on the edge. Mario, do you have something to chime in about this topic as well?
Yeah, we at Solutions for IoT believe that the privacy at the edge is very important, since most of the edge nodes are closer to the users or close to the devices. So the importance of this private sensitive data needs to be kept very, very secure. So normally you don't want to send a lot of data to the cloud, because you're going to generate large amounts of data. The data centers will be overloaded with a lot of information. So you want to train your machines or use the use of intelligence in these edge devices is much more efficient than sending it to the cloud. So that's what we are focusing on.
I see. Thank you, Mario. So it does seem that privacy is going to be a huge benefit of edge AI. But on top of that, I'm hearing words such as latency, and also, just off the top of my head, it seems intuitive that there's also problems with connectivity when it's using cloud. So what do you how much do consumers stand to benefit from, say, also low latency or connectivity issues? Mario?
Yeah, at Solutions for IoT, our background is really mobile networks. So we went through 2G, 3G, 4G, and 5G is now around the corner. So we believe that 5G will solve a lot of these latency issues. But I think the data management of all these data that will be generated is going to be the problem. So really, it's going to be something that we need to focus on solving. And I think edge will be the key to solving this over data.
Okay, thank you, Mario. Geert?
Yes, so as I previously said, so for some applications that are truly real-time driven because of safety, I don't think they will be kind of depending on network transmissions. So even if 5G is around, will take quite some while and will never be kind of fully 100% coverage. So, but a lot of other functions for training, obviously you can collect data, and we have an interesting use case where it's remote control, so operating a car or a robot by a human somewhere else, and then obviously you rely on video images to steer the car to see its environment. And their video latency is really key, because if it's going to 100 or 200 milliseconds, then obviously there's a delay, and that can lead to danger. That's a use case where we help reducing latency significantly, and ensuring safety for the driver.
Yes, thank you, Geert. Now that you go into use cases, I also want to delve into more descriptions of what the use cases look like for Edge AI in concert with the cloud, and also what challenges on the ground there exist in implementing these solutions.
Yeah, I can answer quickly about that. Is that some of the restrictions and what we are seeing now in the world, that we are getting more smart AI solutions that need to be deployed, and they need to be on the edge, because the amount of processing power, the amount of latencies, the gentleman just mentioned, both Geert and Mario mentioned the latency of the network. Okay, that's one thing, but one main thing that we are not they haven't covered or talked about is the fact that these AI hungry algorithms, they need to be processed to be able to function at the edge. They need to be processed fast. So there's a lot of use cases that are emerging from this new use cases that we probably didn't even think about it before. For example, we are working on several use cases, and in automotive industry, as well as access control, is where people now don't want to, for example, touch the locks. They don't want to use the keys to automate the access control. You need to rely on something. We believe it's biometrics. Maybe necessarily not just using the voice, but using two modality, for example, face and voice. You will be able to get a much more accurate result. And the access control now, it's solely run by something you are. You don't have to bring key with you. You don't have to remember any passcodes. And in order to run these two algorithms next to each other, you need to have some kind of neural network acceleration. And if these devices at the edge are not powerful enough, this will be really difficult. We have another use case in Austria. Actually, the motorcycle manufacturer was trying to get rid of the key, and they had automotive grade kind of like a Raspberry Pi thing device. And that Raspberry Pi, the chip on side was some ARM chip. It wasn't good enough to be able to run as complex algorithms as voice, biometrics, or even face. So straight away there we run into the problems. But if they were about to get rid of the key, we have to kind of have something that will be able to enable this in like work with no connectivity, and then you can do ride sharing, sharing of apartments, Airbnb. Quite a lot of stuff can be covered by use cases by being able to run AI directly there without ever leaving the devices. And this is what we see in the market anyway.
I see. So we're kind of in a double bind of, at the same time, we really need high performance. At the same time, we need it to be very power efficient. And that's where the challenge is. Geert, I saw you raise your hand again.
Yes, that's actually one of the reasons why we cooperate with Kneron is that we also like Nikolai we encounter these challenges that more complex models cannot always run on existing chipsets like classical chipsets, and you have it also in automotive and in robots as well. The challenge of keeping the bill of material low, so you can't throw a lot of hardware and CPU power to solve a simple task. So on one hand, is this challenge of keeping its cost low, energy profile low, but still run these more complex AI algorithms very accurately. That's why we see a good cooperation with Kneron. As one example is it's an analogy to what Nikolai just said, but we combine, and not for like key recognition, but actually for recognition of dangerous situations on the road. We combine on one hand, for instance, a lane departure, a lane change, and on the other hand, we combine the face, whether it's distracted, whether it's looking to its smartphone, and these two combined are very rich in content because they give you strong information whether a potential dangerous situation is occurring, and so combining those sensors and information from different sensors into meaningful, in this case, alerts. And there we see Kneron as a partner in order to do this face detection at a relatively low price, high quality, and where we can run our edge algorithms on.
Thank you, Geert. Mario, would you also like to chime in?
Yeah. So in our use cases, what we have seen is in industrial automation, edge computers can help create machines that can sense, detect, and learn without being reprogrammed or programmed. In predictive maintenance, it helps understand and predict when a machine is going to break before it breaks. So that saves tons of money. With Kneron, we believe that we can move into these more camera-oriented solutions that can help in manufacturing, smart manufacturing with solutions like yours. So that's what I wanted to say.
Thank you, Mario. So now we have a view of all these use cases. We have predictive maintenance, we have auto vehicles, and we have, say, locks. And I just want to get more of a sense of at what pace and to what extent are these changes already happening in the market, say, towards the next 10 years or so? And what are the consumers' return on investment on these use cases? Mario, would you like to continue with that?
Sure. I believe that AI will accelerate IoT. I think it's one of the main issues that, or one of the reasons that IoT has not been deployed massively as we expected it, and AI will help explode this. One of the difficulties is explaining to our customers how the return of investment will come. And I think in terms of one smart lighting application that we have is a no-brainer that it will save a lot of money in energy. And that's key to explaining to them how they will get this return of investment. And I believe, there is other areas that I'm not an expert, but we have a good panel here that know a lot of automotive and so on. So, but that's the areas that we've been exploring. So I hope to hear what they have to say.
Yes, thank you for your insights, Mario. Geert, do you want to talk a bit more about your space as well regarding the same question?
Yes, for sure, Sabine, and thank you, Mario. Yeah, I want. So on respecting to return on investment, we would say customers are looking for a maximum of 12 months return on investment as a rule of thumb. What may be more important than of what may be a part of a return on investment is actually the quality of the algorithm. So what Teraki is able to bring to the table is the 30% higher accurate algorithm. And an algorithm or a machine learning model actually produces a better product or a new service, and the more accurate that product or service is, the higher the business benefits. So either in revenues or in customer satisfaction. And when you're considering a return on investment, it should also include kind of the downstream benefits of the algorithm that you're actually running. Whether it could be safety in the increased safety in a car, increased comfort, or just new services to customers. So that is an important part. And with chipsets, current chipset, they run 10 to 30 watts, and we see that one needs 1 watt chipsets, and with the Kneron chipset, we can make such a marriage our increased algorithm accuracy for our customers, runs at low power, and with that we always discuss with customers their business benefits and try to stay within 12 months of return on investment.
I see. Thank you, Geert. So I think that's a very good illustration of how customers need to understand how they stand to benefit. But at what pace do you think the sort of understanding is in process already? How well is the market understanding these facts? And also, just to what extent do you think these benefits will be accessible in the market? Is it going to be more of a particular segment, or do you think it will be a very commonplace technology to see in the next, say, 10 years or so?
Yeah, I would not say it's limited to a certain industry. So I think it goes as for automotive as for other mobility services. We focus on robotics, delivery robots, and drones as well, for instance. My colleagues here, Mario and Nikolai, also focuses on different industries as well. So I don't think it's limited to a specific industry. Secondly, you do see some differences between regions in the world, and also between kind of large corporates in how quickly they move innovation to the market. And I think this will only accelerate in the coming years due to some kind of competitive threats, and companies that do bring new products and new features to the market will drive the pace and either force others to also join or to reinvent themselves in another way.
Thank you, Geert. Nicola, would you also like to chime in about the space of voice and biometrics?
Absolutely. So one of the things that both Geert and Mario mentioned, it's actually completely true. Like it's I don't think it's going to be one segment alone. It's going to be several segments at the same time. What we at MyVoice also believe in, that the shift that we are moving now at the edge, and especially what Geert was saying about processing data and having, being able to kind of show the return on investment, I think that will exponentially grow. And the reason why we think it will grow, because new business area will emerge. So suddenly we will have new business models, new business areas that probably none of us even in the room are thinking about. So at the end of the day, it's not the best technology to win or the best algorithm. It's technology that enables something different, a total paradigm shift in how we are doing stuff. For example, 3-4 years ago, before we started MyVoice, me and my co-founder went to Silicon Valley, and one of our advisors, Byron Han, who spent 30 years at Apple, told us the best technology in the world is the technology that you don't see. So if we can use edge AI to improve the lives of the people around us without them actually noticing directly what's happening, I truly believe that we will have a more efficient and a better decisions will be made. For example, for factory automation and what Mario was just discussing now previously, you have a lot of factories, especially here in Norway where I am. They're very efficient, but actually they could save 30-40% less energy if they used algorithms at the edge. Okay, tomorrow is minus 10 degrees or plus 10 degrees. Okay, automate, put the air conditioner on earlier. If this is powered singularly by every edge device, looking at the weather, looking at of the production cost. All of this is dancing, like you said, in symmetry, not necessarily in a cloud. It can be dancing at the edge as well. I think we will be saving a planet a lot of resources, and we will get a more effective future for everybody.
Thank you, Nicola. Now that actually, I'm also very interested in what Mario was saying earlier with regards to predictive maintenance. If I'm getting that, so as we can sense, that's going to probably be quite revolutionary for society at large in terms of what consumption would look like, what the cost would be for things we are very accustomed to. Mario, what would you say, like as a big picture, how does edge AI technology in your space impact society at large, and how can we see the manifestations of that?
Yeah, I think edge AI is very important as it continues to, as companies continue to make AI type of MCUs or microcontrollers that have already some AI platform in them. For example, we have a customer that is using our platform, and they are doing agriculture. So they have a bunch of sensors to do predictions on, based on data that is gathered, like humidity, temperature on the air, temperature on the ground, and so on. They can optimize the growth of plants. And I think as our population is growing, we need to use the resources more efficiently. And they are on a great path to do this, and we are seeing it in Latin America, where they're not very efficient in using technology, and as they are getting smarter in doing these predictions, they are asking for more and more information, and having more artificial intelligence in the microcontrollers and in our solution. So that's what I think we need to be, and we need to go.
Thank you, Mario. Yes, so that certainly does illustrate the extent to which edge AI is going to be shaping how we go about in markets and save costs, and also impact human lives throughout society. Going back to Nicola earlier, you were also talking about the same topic, and could you please dive in a little bit more as well as to how biometrics is going to look like as a landscape in the future, if you have to paint a picture, say for instance, for the consumer and average public to visualize?
Yeah, definitely. So the way kind of we look at the market and why we believe in voice, it's the fastest, it's not the next user interface. We believe it's the final. As you can see now in this talk today, we can give so much more information by talking rather than writing. There's like a higher speed of not only receiving but also giving information. And how we believe this will shape the world around us. We believe that your user account, your identity, your digital identity, for example, currently now it's tied to account. So if you have your Google Home or Amazon Alexa or whatever it is, you're tied to account, you need to type a password. And then if you go to somewhere else, or to somebody else's house, that's basically useless. So we believe that you will be able to go from your home to your car to your office and basically carry that biometric identity with you regardless of where you are. So what will happen then is that you will suddenly have a more streamlined way of living. So you will be able to say, hey, hey MyVoice, or hey Google, whatever device it is, and say, hey, can you order a pizza for me and Mario and Gert? And just by you saying this, you would not only order a pizza, it would understand the meaning, it would charge it biometrically to your bank account, which is again tied to your voice and your face, but now in this instance voice. So we believe then that the future, how we see today, will rapidly change. Some of the use cases around automotive, for example, automotive industry, we work quite a lot in Germany, and they're not looking at the car as as a car anymore, as a transport vehicle. They're looking at it as a platform. So now imagine if you look at the car as a platform, what kind of services will come on top of it? Who will benefit? Insurance companies, will we be able to do banking while you're driving? Eventually you won't even drive the car. You will sit in it and use it at your office. So maybe that future is 10 years in front of us, but everything else is moving rapidly. So it's quite exciting time we live in. And one thing I wanted to mention that I forgot to say previously is that we have a lot of supercomputer and a lot of computing power around the world. But where I believe we will move is that we will have a swarm. Like if you look at a swarm of bees, we have a lot of these small microcomputers, microchips like neurons, and they will work around everywhere we go, and they will talk to each other, and they will make decisions, better predictions and everything, rather than having one centralized unit that operates in a cloud and has sensors at the edge. So I believe we went to cloud, big data. I think we are now still having big data, but it's becoming smaller and less reliant on large models and everything. And it's exciting future.
Thank you, Nicola. So a federated, decentralized system that allows me to not have to remember my passwords anymore, which I have a knack for forgetting. That certainly is a future I'm looking towards too. And as we are now out of time for this panel, I would like to thank you all, Mario, Gerd, and Nicola, for your time and insights. It's truly been a pleasure speaking with you all, and we look forward to see the advancement of Edge AI in your spaces and how we can make AI accessible and beneficial for everyone and everywhere. Thank you.
Thank you.
So we really hope that you enjoyed the panel discussions today. I, for one, learned a lot, especially since we got to hear from so many different vantage points. Edge AI is coming, and it will transform how we interact and experience AI on all levels. Kneron's mission is to enable AI for everyone on any device while maintaining user privacy and data security. So join us now for our Q&A session. Simply click on the session icon on the left-hand panel of your Hopin interface, and we'll see you there.